Hello everyone and a very good morning to all of you. Distinguished delegates, presenters and participants from SAARC member states and other regions around the globe. Ladies and gentlemen, I'm very thankful to all of you for joining us in this webinar to disseminate the study on infrastructure and enabling environment for road electric transport in SAARC member states. My name is Mohammad Umar Mukhtar and I am working with SAARC Energy Center as Research Fellow Energy, Transport and Environment. I shall be moderating today's SAARC webinar, the aim of which is to highlight and promote the numerous benefits that the use of electric vehicle brings to common consumer and the governments, and to disseminate the information among the policymakers, regulators, researchers, academia members, and other stakeholders from the SAARC member states. The world is facing the challenges of air pollution and greenhouse gas emissions due to the conventional internal combustion engine based vehicles, and the transport sector alone contributes almost 23% of the global CO2 emissions. As electricity is going to be the largest source of energy in the future, and the electrification of the transport sector will certainly help tackle air and noise pollution, besides reducing hydrocarbon fuel import bill for the fuel-dependent SAARC member states. Therefore, policymakers are now looking towards integration of EVs in the transport sector. One of the most essential factors to bring about a shift of the conventional transport sector to electric transport in South Asia is the building and maintenance of the necessary charging infrastructures and enabling such conducive policies that will make it economically easier and viable for the consumers for massive uptake of electric vehicles. Realizing the need for thorough assessments and analysis for EV uptake, SEC conducted a study in 2018 to assess the infrastructure and enabling environment requirements for the successful and effective integration of electric vehicles in the transport system of South Asia. This study was carried out by India Smart Grid Forum. A workshop to disseminate the findings of this study was scheduled in 2019. However, it could not take place, and as a result, the workshop had to be postponed. So this year, in order to disseminate the findings of that study and to get feedback from member states for value addition and to build awareness among member states, SEC has now organized a dissemination webinar. The participants of today's webinar are from relevant government departments, research organizations, academia, associated industry, and private sector, specifically from South Asia. I am extremely grateful to our panel of presenters who have joined us today. We are joined by Mr. Reji Kumar Pillai, President, India Smart Grid Forum. Ms. and Mr.
We can't hear you.
So we can't hear you, sir.
Yeah. Good morning, good afternoon. Am I audible to everybody?
Yes, you are audible.
Okay. Good morning, good afternoon to all the distinguished participants in this program. My name is Reji Kumar Pillai. I'm the President of India Smart Grid Forum. We are honored to have been assigned by SAARC Energy Center for the study on infrastructure and enabling environment for road electric transport in SAARC member states. This assignment we carried out in particular, mainly in the second half of 2018, and the report was submitted in December 2018. We tried several times to have this presentation in one of the cities in India or one of the SAARC countries in 2019. Due to mutual convenience of all the SAARC member state stakeholders, it could not happen. And now we are at least doing it on a digital platform. So electric transportation presents a great opportunity for SAARC member countries. Many of them are dependent on imported oil, and particularly the landlocked countries like Afghanistan, Nepal, Bhutan, who import petroleum products, refined petroleum products from other countries, and run their ICE-based vehicles which pollute the entire environment. These countries are also have very high potential of electricity potential, which can generate clean electricity that can power the electric vehicles. In the last 10 years, the price of batteries, which has come down by almost 90%, over $1,100 per kilowatt hour. Lithium-ion battery prices today stand at somewhere $125 to $150 per kilowatt hour. So the cost of electric vehicle is almost going to be in a year or two comparable with the ICE engine-based vehicles. And if you take the life cycle cost, it's already economically advantageous to go in for electric transportation. Another important point I like to mention is that out of the 20 most polluted cities in the world, 16 of them are in India, 3-4 of them are in Pakistan. So SAARC countries represent almost 90% of the most polluted cities in the world, Delhi being the most polluted. We used to have typically 400 to 600 ppm of PM 2.5, which has everybody thought that it will take several years of effort to bring it down to acceptable limits, which are about 25 to 40. But the COVID has proven that this damage, environmental damage which you have done, is really reversible in a very short time period. Today, Delhi, from the 450 to 600, it has come down. It has come down to 25 to 40 PM 2.5. So electric transportation really, there are a lot of background noise. Those who are not speaking, I request them to please go on mute. So electric transition to electric transportation presents a huge opportunity both for economic opportunities as well as for environmental and health betterment for SAARC countries. In India, we launched a mission on electric transportation in way back in 2013, and as you know, transportation was the in every country, transport is something which was done by the transport ministry, and they never contacted anybody else in doing anything to do with the transportation, highway, road. Those ministries were entirely different. Policy makers, regulators, they were all different. They carried this electric transportation mission also on that mode without having any discussions with the Ministry of Power or other stakeholders who need to give them electricity to charge the electric vehicles. So way back in 2013, when India announced a mission with a target of 5 to 7 million electric vehicles by 2020, there was hardly any input from any other participating ministries or stakeholders. It was India Smart Grid Forum which took up the issue, brought to all the stakeholders. We brought everybody together. At that point in time, even according to our existing electricity law, for a third party to set up a charging station, buy electricity from the electricity company or a distribution company and sell it to an electric vehicle owner, to the electric car, that was a sale of electricity by third party which was not allowed in the Indian Electricity Act. There are so many other barriers of electric mobility which were all raised by ISGF, and in the past couple of years, government has came out with many enabling laws and regulations. Similarly, charging standards, the electric vehicles which have been imported in India and running currently on the road, majority of them are partially or fully imported from China, and they follow GBT standards. So the next set of India, otherwise, like many other SAARC member countries, we all follow IEC standards in electricity. So the European standards for electric mobility are the CCS or combined charging system standards. When we started writing a standard for India, we thought we will go in the CCS way, and we will also allow for some transition time. We'll keep the Chinese GBT standard because we already have those vehicles here. But when Government of India invited globally car manufacturers and other automobile manufacturers to come and set up manufacturing facilities in India, it was the Japanese and the Koreans who responded first, and they follow SHADAMO and they're a different standard. So finally, in the standards which Bureau of Indian Standard issued 2 years ago, it's IS 17017 series of standards. 3-4 of them we issued. We still have some pending, which is on the connectors and pins, etc., which we will be completing by end of this year. So we allowed CCS and SHADAMO both in India, and also we allowed the existing vehicle, the GBT, to coexist. By and large, all standards can coexist. This is again a very important issue to be considered in smaller countries, whether what standard to follow. There are many things. The roadmap which we prepared for each of the 8 countries, we looked at the maturity of the transport sector, the road transportation scenario there currently, and the growth prospectus in the next 5 to 10 years, as well as the electricity distribution system there and the future of electricity in those countries. And we recommended specific roadmap for each one of them. And we used a tool which developed by India Smart Grid Forum. It's electric vehicle maturity model, which we developed very much online with the Smart Grid maturity model, which is with the CMU or the Software Engineering Institute at CMU. We have been using that model for the past several years. For the SGMM, we have been using for Smart Grid roadmap. So something similar, we ourselves have developed this electric vehicle maturity model, and that is what we have used for looking at the maturity of each of the countries and SAARC member states and recommending a roadmap for that. So what is ISGF and what activities we have been doing? I will request my colleague Reena to take you through next 10 minutes through a couple of slides, and thereafter my other colleague Surasata Kundu will take you through the specific roadmap which we recommended in this study. So and I am on standby. Any question, anytime, I'm available throughout the webinar. Thank you very much. Over to you, Reena.
Very good morning to all. Thank you so much, Mr. Pillai. I'm Reena Suri, Executive Director with India Smart Grid Forum. I've been in this sector for 20 years and primarily responsible for the research projects, advisory services, business development, training, capacity building programs, etc. with ISGF. So to take you through ISGF, how we were conceived and what are the various initiatives that ISGF has been working on. ISGF, India Smart Grid Forum, is a public-private partnership initiative of Ministry of Power, Government of India, for accelerated development of smart grid technologies in the Indian power sector. Its mandate is to advise the government on policies and programs for promotion of smart grids in India. We work with national, international agencies on standards development, help the Indian electricity companies, the regulators of India, the industry in technology selection, training and capacity building, and research projects. We have over 200 members comprising of ministries, utilities, technology providers, academia, and research organizations. And with that, we have evolved as a think tank of global repute on smart grids and smart cities. Next, SK. So some of the activities ISGF has undertaken in the electric vehicle space and better adoption of electric vehicles in India and other countries. We have done a very first of its kind study was conducted by ISGF, a detailed techno-economical feasibility analysis and development of implementation plan for introduction of electric vehicles in the public transport fleets in the city of Calcutta in West Bengal state. We worked on the state transport corporation in Calcutta, West Bengal, in the establishment of charging infrastructure to facilitate the deployment of the very first 80 buses that were rolled out in the city. We further provided advisory support on scaling up of electric mobility deployment for the transport department in West Bengal again. We also conducted a feasibility study and prepared an action plan for the introduction of electric vehicles in the Indian suburban landscape with special focus on the forest fringe island, parts of suburban Sundarbans in the West Bengal state of India. We also worked on, since there was a huge penetration of electric vehicle and huge demand was envisaged, so how the electric utilities need to prepare. So for this purpose, we have initiated a study in the Bangalore city of Karnataka in India to prepare a detailed plan for deployment of EV charging infrastructure and associated grid upgrades required for managing the demand increased or created by the electric vehicle that will be connected to the grid in the near future. We also conducted a study on infrastructure and enabling environment required for the road electric transport, as mentioned by Mr. Pillai, and we'll be discussing the results of this study in detail soon during the session. We have worked with different companies on putting the proposals for the government scheme, Indian government scheme called Faster Adoption and Manufacturing of Hybrid and Electric Vehicles. It's called FAME scheme. And for that, to boost the electric mobility and increase the number of electric vehicles, proposals were invited by different organizations to deploy the EV charging infrastructure in various cities in India. As mentioned by Mr. Pillai, we also work on standards required for the EV charging infrastructure. We also work with different states in India for helping them in formulation of the electric vehicle policies required. Next, SK. Yeah. So we also work with the regulators in India to formulate the creation of tariff slabs for the EV charging. We have special rates for electric vehicle tariff in different states in India. Yeah. For disseminating the information and coming out with better EV electric vehicle charging business models, we have also conducted various brainstorming sessions with the different stakeholders and submitted the recommendations to the ministry. We have worked on various white papers, including the business models for creation of enabling ecosystem for faster rollout and adoption of electric vehicles in India, looked at the charging technology available, the standards that will be required, business models that will be that were reviewed, looking at the international best practices, and what will be the best possible options for India. And studied the policy and electricity tariff for EV charging India for faster EV rollout and adoption, and the sustainable solution for air pollution in India through rollout of electric vehicles, the impact that will be there post EV deployment, and the policy measures required to accelerate EV deployment in India, and some other various important papers we have worked on. Next. We work very closely with the government on its smart grid initiatives. For this purpose, in Ministry of Government has come out with a framework for National Smart Grid Mission, which is as a mission is there to further enhance the smart grid projects in India. We have worked on creation of the framework, very closely working with the mission to achieve the goals that they have set. We worked with the Indonesian utility, PLN, on preparation of the smart grid roadmap, which outlined the activities that PLN can undertake over a specified time frame to achieve the state goals and its expected outcomes for taking up the smart grid journey that they were planning. We have done a similar smart grid roadmap for the Bangalore utility in Karnataka in India. And we worked with SAARC Energy Center on another roadmap, development of the roadmap for implementation of smart grid concepts, practices, and technologies in the SAARC region, which is also available for on their website. Regarding the energy storage systems, we worked with the government on preparing a roadmap for reliable and low carbon grid for successful deployment of energy storage in various sectors, including electric vehicles. This is a very first of its kind study we are also have undertaken in one of the states in India, in Uttar Pradesh, to do a POC for pilot on peer-to-peer trading on blockchain technology for the solar power of customers in Uttar Pradesh. Apart from that, we are currently designing the time of use electricity tariff for Gujarat state. And lastly, we did an intensive study of the smart grid market scenarios in India. Next. So I think there are a couple of more studies we have undertaken, and you can go through our portal or indiasmartgrid.org and you can download and study the reports that we have put together. I think that's all from my side. I'll be happy to take up any further questions if you have about the forum. And over to you, Sudha Satakundu, for taking you through the study results.
Thank you, ma'am. And thank you, SAARC Energy Center, for giving ISGF the opportunity to carry out the study. And I am Shuddha Shatta. I'm working with India Smart Grid Forum as a senior manager in the technical advisory domain. And the study we carried and we submitted the report in the first half of 2019. And the project, I will just brief you about the project and the objectives that was there for this SAARC. This study on the infrastructure enabling environment for road electric transport in SAARC member state. The project purpose was to readiness assessment for transition to electric mobility and subsequent formulation of EV implementation plan for the SAARC member nations. So as our president, Mr. Rajiv Kumar Pillai, already mentioned, the EVMM that we have already developed and used for the preparation of the roadmap. So first, on giving this, coming to the recommendations on the roadmap, we first assess the readiness of the transition for the electric utility. And the key focus areas for the readiness assessment was the global EV scenario, so that we can understand what are the steps taken by the internationally or the other countries which have already accelerated the deployment of EV. Then the EV infrastructure and policy requirement, the global best practices for EV adoption, global best practices actually from the transport as well as the electrical utility perspective. It's not because it's electric transport, so we have considered both the aspects. And then the readiness assessment for the sub-countries, combination of these have gone for the readiness assessment of sub-countries. And for this assessment, what we have identified the gaps, what are the gaps that need to be filled up from and we have taken the examples from the global best practices, but what other countries have done on to accelerate the deployment. And we have used those practices to for this, and the EVMM model we developed, and we have prepared the recommendations. The key interventions that we have considered was the policy and regulatory, the business model and tariff design, the electric grid upgradation, and the institutional development. Suppose if first the policy should be conducive to the deployment of electric vehicle, then the business model and the tariff design, what business model we should follow, the electric grid upgradation, because with the more number of electric vehicles connecting to the grid, then there's an upgradation needed more on the smart grid side or the capacity side or the network upgradation. Then the institutional development, because it's a new area and this institution need to work together. Not only the transport department, electric department, other departments like municipals and others, this urban management departments need to work together, and what development capacity building should be done. So the outcome was the creation of an enabling environment for the EV adoption in each SAARC member nation. And what we did in the roadmap, we divided it into the various phases and the steps that need to be undertaken in those phases, so that to create the enabling environment. Then the approach and methodology, the review of the global EV deployment in terms of technology trends, market evolution, and vehicle stock that I've already discussed on that key. What are the things that we have already considered? That is the first, we reviewed the global EV deployment. Then the assessment of EV infrastructure requirement. What are the infrastructure that is needed for EV, for the deployment of EV, like charging stations, standards, communication protocols, grid upgradation, and everything. And the review of the best practices. Then we review the best practices that has been adopted by the global 3 leaders. Then we assess the readiness of sub-countries. So first we did that, what is the global EV stock, then we prepare the best practices, then what is the assessment of the infrastructure, then we assess the readiness of stock. We combine implementing using all these three, the knowledge that we gain from all these three that has been applied to this for the assessment of readiness assessment, where we assess the SAARC countries in terms of policy, regulations, institutional capacity, and technology deployment. Then the recommendation for SAARC countries with respect to this policy support institution and others using the EVMM that is already mentioned. EVMM maturity, electric vehicle maturity model framework, has been used by the preparation of electric vehicle roadmap for the SAARC countries, and details of EVMM process is explained at the slide number 40 and 41. Now, coming to the global electric vehicle scenario, as this is the annual electric car sale registered a milestone of 5.1 million plus in 2018. The global electric car stock stands at 5 million in December 2018. So you can see that the four-wheelers, the buses, and these charging stations, the two-wheelers, these numbers are getting quite high nowadays. And this the global two-wheeler sales of 300 million for 2018, and two-wheeler stock stands at 800 million. So China has done a very well, because we are in the study also we have taken one case from China, and the China has the highest share of 99% in the two-wheelers. And this buses also, you have heard about this engine. And India Smart Grid Forum, actually our president Mr. Ajay Kumar Pillai has visited this engine facility and wrote a paper about it. You can find it on our this indiasmartgrid.org website, how this engine managed to, the Shenzhen city of China has managed to manage the transition of the buses into the electric buses, and it has completed completed the 100% transition. So you can read about that article written by our president in the ISGF website. And the growth of EVs under the different policy scenarios, new policy scenario, the two-wheelers and three-wheelers in light-duty vehicles, you can see it will be 12. I think it's 12 million, and then this 2030 it will be more than that. The buses are going to be 1.5 million by 2030. The EV30 at the rate 30 scenario, that is the EV30 is an organization, as a consortium, which is giving that two-wheelers and three-wheelers by 2030 will be more than 58 million. I think 585 million, and then the light-duty vehicles will be much more. The buses will be 45 million. So if you can see that the number of vehicles, growth of EVs under different policy scenarios, and the EV30 is increasing quite nowadays, and it will be almost there is in most of the countries there will be 100% transition by 2040 or 2050 to these EVs. And for these we require a high number of charging stations, and then not only the charging station, the standards and protocols. We have to keep in mind the interoperability, because there are various charging standards are there, and we need to when number of electric vehicles will be more, and there will be the interoperability needs to be there to ease the usage of these charging stations. And then the grid upgradation that is required with renewable energy coming up, and the using of this renewable energy to use to charge the EVs, the storage and everything. That the electric sector and the transport sector will be interdependent on each other, and all the smart grid and everything will be a catalyst for them. And the types of EV, that is the battery electric vehicles, hybrid electric vehicles, plug-in hybrid electric vehicles, or fuel cell electric vehicle, that gives a comparison on this, but mostly we focus on the battery electric vehicles because there is no usage of this fuels, and except the fuel cell, which is already I think it's already in the R&D stage. But it's not commercially feasible about the fuel cell and using that. So you can see the various features and the challenges that is there. Already the batteries, about the battery, the lithium-ion battery the cost of lithium-ion battery has already reduced by 90% in the last 10 years. It is available between $125 per kilowatt or $150, as stated by our president already. And then this is the challenges and the high cost compared to IC vehicles. But in the next 3 to 5 years, I hope this challenges will be overcome. The lack of charging infrastructure, already countries like India has already started this charging infrastructure development by coming out with various schemes. Like under FAME 2, there was around about 3,000 charging stations are given under subsidy to different cities. And then this battery and the battery maintenance, these things are coming up. The relatively short range, the short range has already been improved. There are buses in India that's running about 250 kilowatt hour battery, and the cars that the Hyundai Kona that has come up recently has a range of around 300 to 400 kilometers per charge. So these challenges has already been overcome. The features, high efficiency, oil independent, commercially viable, we are well aware of that. That's why we're promoting these electric vehicles. Obviously, this hydrogen fuel cell vehicle has already is under the R&D stage, this fuel cell technology, and the commercial viability are getting checked, and how it will be reliable, and all the scalability are also being checked. So these are types of EV. You can go through that on that, and we are not touching up the hybrid and plug-in hybrid because already we have moved to the BEV, and we don't want to get into this again in the full thing. The existing battery technology. There's the various battery technologies like lithium-ion phosphate, the lithium-ion NMC batteries, the lithium-ion and this NCA batteries. There are various versions, and this NCA batteries, the lithium-ion titanium oxide, LTO batteries. LTO batteries are actually these are the very costly batteries but they have a very high charge rate. The C rate is the charge rate of the battery. Suppose the C means if a 60 kilowatt charger charges a 60 kilowatt battery, it will take 1 hour. In 6C, it will be reduced by 6 times. So means it will be charged in 10 minutes then with the LTO battery. But it is not commercially viable right now, and it's very costly for the NMC batteries, and this lithium-ion iron phosphate batteries are being used nowadays. NMC batteries are being used already in India. Some of the electric buses are running on the NMC batteries 811, and this is the charge rate having a C by 2 on that, the maximum temperature. However, this power density is very high in the NMC batteries. Whether the charge rate is less, but the power density is very high, and the very good but the life cycles. Currently, the life cycles are okay in the current scenario with lithium ion getting high life cycle of 1500 to 3000 cycles, and this LTO has a very high life cycle, but the power density is very less. So if you see the price also, you can understand the average price model for the lithium ion phosphate is 270. That was priced in 2018. It has already been reduced. However, this is a combination of the battery and the battery pack. Not only on the battery cost is reduced much, but it's only the battery. It also consists of the battery pack that cause that issue. Now, various EV business models that have been followed globally, and this is the one is the aggregator model, where the coordinating between the system operator, EV owner, and distribution utility. It collates the aggregator, collates the EVs, and create a potential source of energy that can be used by the utilities and system operators during the periods of high demand supply gaps. But that is the concept of vehicle to grid, and that concept has not been in India. Countries it's not been developed, and but in other the pilots are running in USA and other places. I think in California the pilot is running, and this owner model, where they integrate large fleet EV through individual vehicle owners who then directly participate in the energy market. EV owner receives signals and directly manage the request from utilities and system operators with the help of two-way communication and control systems. Actually, this is more of a, you can say, demand response, or this where the EV owners can react to the price signals from the operators, and where they have been used for this. This can be achieved optimizing the charging price so that the EV owner can minimize the charging cost at all times, while reducing the stress on the power grid. So when there will be a price signal from the operator, EV can charge at the lower price during the time of day or time of use tariff is there, and other times when they have the benefit and they have the price is high, they can produce and they can give it back to the grid. Discoms will be the owners and operators. In various models have been proposed. Actually, some are the grid operator of the discoms in the areas, They are doing Ireland like ESB, which is the grid operator. They are operating the charging stations, and to facilitate, because the network operation, everything is handled by them, so it is easy for them to put up the charging stations, and the tariff they decide can be spread throughout the consumer base, so that there will be a very little increase, actually very little increase in the price in the tariff, cost in very little increase in the tariff actually, because when you are passing on the whole cost of for setting up the charging station throughout the whole of consumer base, then there will be very little increase in the tariff, and that can be, that is a political decision again. In the bus depots, the STUs themselves will be the owners and operators of charging stations. The transport utilities can operate, like in Calcutta also with the project, the transport utility is the owner of the charging stations and the operator of the charging facilities of their own buses, and the other buses also, where they allow some of these, they've already made that provision that if the other buses like private buses want to get charged there, they can do that. But currently the private buses are not being electrified here in Calcutta, but the state transport utilities are doing that, not in Calcutta, in other states also. In Uttar Pradesh, the state transport utility is taking up those this charging station ownership. The battery swapping, the battery charging could be at public facilities at their one captive industrial establishment. Actually, battery swapping model is also being tested in India in one of this city called Ahmedabad, and where this testing facility and these batteries, some Ashok Leyland buses are there who are swapping their battery during the movement. But in battery swapping, like when we compared with Calcutta and the Ahmedabad, the only problem will be that the Calcutta, in Ahmedabad, there is a BRT, the specific route for the buses already there. So the time, the congestion and other things doesn't affect much, because in battery swapping, it is being tested with a very lesser amount of battery, like 48 kilowatt of battery was there. And that is and the buses are there, so the consumption is very less due to the traffic, due to lower traffic and the less congestion because of this BRT, and the distance is short, so there that is feasible. But in Calcutta, when you made the calculation and do the calculations, it's not possible for in Calcutta, because due to the, then the buses need to charge between from one destination to another destination, from one point A to point B, they have to charge in between, they have to swap the battery in between. But in case of charging stations, they can easily go, they have a high capacity battery and they can easily go to the destination and then charge there for a few minutes and as an opportunity charging, and then come back to the source. This is the franchisee at parking lots and municipal facilities. There are discoms, franchisee discoms will own and operate charging facilities at premises allotted by city governments, municipalities. It is being, in India, it is being given to the private players also. We can own, we can do some, who can put up the charging stations in the city governments or municipal, city government, with the help of city governments and municipalities in the parking mall and this small parking, and then other parking areas, or near the bus stations, or you can say the railway stations, where they can do that, or inside, because in India also there is that 20% of the residential area is also should be reserved for the parking. There's a regular guideline on that. So inside the buildings premises also, the facility is there, so various people can put up the charging stations along with the permission for the city governments or the municipalities. Now, the electric vehicle key drivers in the SAARC countries are the limited availability and depleting fuel. You can take the example of Bangladesh itself, because Bangladesh, due to this transport utilization of gas, actually, it is already there in our study that the gas utilization in transport sector has deprived the other sectors of gas, like in power also, and fertilizer sector is mainly deprived of gas in Bangladesh. So Bangladesh is also taking up this coal and other form of generation. So this limited availability and depleting fuel, some of the countries are importing the diesel and petrol also for these cars, which are not there. Their cost is very high, the high cost, and the significant amount of budget actually goes into this transportation of fuels. Then this GHG emission, and from the transport sector, there's always there is a GHG emission case is always there from this diesel and petrol, and which is we're moving towards a sustainable development. So we should factor into it when deciding for some of the future transport and others. The volatility in oil prices, that provides a lot of pain, and actually when you are transporting a lot of fuel, the INDC the commitment, that is the NDC commitment, national determined contribution towards the UNFCCC commitment for reducing of the carbon, GHG emission, and the deteriorating of air quality, the health condition in India, in other places in India, in Delhi and other places, the air quality index is very high, so having more than 500 AQIs, that is very bad for health actually. So that is very risky in terms of health. And the SAARC countries, the existing scenario, but we have studied on that. The country Afghanistan, that is Bangladesh, that installed power generation capacity, crude oil imports. You can see the India, this Pakistan, and Sri Lanka, the crude oil imports from in various years. The petrol imports, and what is the in USD million, the diesel imports in USD million. We have put some remarks also. So on this, on that we have taken this because it's a desk-based research. So we took some findings from the SAARC primary findings, and this is power division from the, we can see the sources. We have contacted the governments, and with the help of SAARC Energy Center, we got some data on this. So you can see the amount of oil imports and the petrol imports is very huge when you compare to the other things. And this cost is significant. This impact a significant cost on the budget. So instead of allocating most of the budget in the health education, and we are allocating spending so much budget here, so that can be developed, that can be waived off this transport thing of crude oil and the petrol imports. So for the transportation sector, at least that can be avoided. And in countries like Bhutan and Nepal, it's abundant hydropower is there, as mentioned before, so it can be utilized for generating more of electricity. And we can do, because Bhutan is also exporting, planning to export power to Bangladesh, and already exporting power to India. Nepal is also exporting power to India. So at that time, at least we can use the electric vehicles, and that power can be utilized for the electric vehicle and for the charging facilities and the growth, and to deploy the electric vehicles. Now the SAARC countries, that is the transport sector scenario. If you see the share of transport sector in consumption of oil, which I'm saying before, like Nepal 65%, Sri Lanka 69%, Bhutan 59%, India 47%, Pakistan 48%. So it's very high. None of the countries are doing good on this. So it's very high. So we can cut on that with the use of electric vehicle. The GHG emission, you can see the 16%, 6%, and 11% is also quite high. The transport sector of each SAARC country has a contribution of at least 7% in the respective GDPs, and we're contributing 7% in the respective GDPs, and your transport sector consumption of oil is very high on that. The registered motor vehicles, the SAARC region has 230 million registered motor vehicles. So if we can convert that, you can imagine how much we'll save on this transport of this import of the petrol and diesel, and also the GHG emissions. And transport sector contributes to 6 to 27%. So it's also very high. So the whole purpose of this slide is to show that if we can move from the transport sector to the EV, means from the fuel-based transport to EV, then we can save much on this import of the fuel oil and petroleum products, and we can save much on this GHG emission. So which can lead to a sustainable development, and we can allocate our budget to other areas like health, education, which can improve the economy of the country. Now, key recommendations of this study, I think, Regissa, are you there? Hello. Because then I think we'll carry out with the EV roadmap. I will request him to be there to explain this EVMM, the electric vehicle maturity model. That hello, so you are there?
Yeah, you come to slide number 40 and 41.
Right.
Yeah.
Is there, sir?
So yeah, I'm there. So again, good afternoon to everybody. So far, whatever been discussed, anybody has any question, I'll be happy to answer, and then take you through a brief introduction of electric vehicle maturity model, which we the tool which we use for assessing the readiness of SAARC member states on electric mobility. Anybody, any questions?
Sir, we do not have a question voice now. We will take that in the end of your presentation in question and answer session.
Okay. Yeah. So you can also suggest to everybody, those who have any question, they can type the message in the message box, so we all know what question has come. So electric, I believe many of the people who are on the webinar today would have heard of a tool called Smart Grid Maturity Model, which was developed by a set of forward-looking utilities, American Productivity and Council, and later transferred to the Software Engineering Institute at Carnegie Mellon University. So it is the SEI, or Software Engineering Institute at Carnegie Mellon University, which developed some 20 years ago a capability maturity model for the software industry, which has become the foundation for all software developments, how softwares are developed so that it becomes interoperable, or a large number of developers can work on different modules. So when the smart grid initiative started early in the 2000, 2003, 2005, different people have different views about the smart grid. Somebody said it's a SCADA and automation is smart grid. Someone else said that it's all about smart metering. Someone else talked about the IT systems. So a comprehensive view of smart grid was missing. So this tool was developed by some of the utilities and other technology companies and American Productivity and Quality Council together. They divided the entire operations of an electricity company into 8 domains: strategy and regulatory matters, organizational structure, grid operations, work and asset management, technology, customer, value chain integration, environmental and societal. Like that, 8 different domains they divided the entire operations. And it's much like the CMMI, the maturity, the default they put it at 0, and level 1 what need to be done to come to level 1, and from there what need to be done to level 2. So 8 domains and 5 different levels of maturity, and after the default level, so about 40 different blocks you will find, and each one of them there are clearly measurable characteristics we are put in. How to measure a utility on grid operations are on level 1 or level 0, which is default, or level 3, or on technology they are on level 1 or level 2, and also what need to be done for ascending from level 1 to level 2 in each of these things. So that was a very successful tool. Many people try to emulate something similar around the world. 2009 onwards, it is being hosted by SAI at CMU, and a couple of later versions also came in 2013. But 2018 they have made it public. Anyone can use it, and you can make it in any amendments to that. So ISGF has been using this tool right from beginning, and we use it for the smart grid roadmap for a couple of utilities. So drawing inspiration from the SGMM or smart grid maturity model tool, we developed something called the electric vehicle maturity model, and that we have used. So this is a tool which we can use to assess the readiness of a country or a city. It can be for a city, it can be for a country, for adoption of electric vehicles in terms of policy, infrastructure, technology, institutional structure, market dimensions, customer acceptance, etc., which will help stakeholders, including the concerned government, public transport utilities, taxi or fleet operators, electric utilities, EV and battery manufacturers, the electric vehicle charging station or EVSC service providers, to identify and implement the required step that need to be taken in a phased manner to ensure sustainable EV adoption across the country or the city. So next slide, SK. Here we divided the into 8, same like 8 different domains. First one is vision, policy, regulation, institutional capability. So how do we build that? Without that, electric mobility plans will not be sustainable. It will not it cannot be implemented as it is envisioned. So the roadmap for incentives, there has to be a set of incentives. If you look at it, every part of the world, there has been different incentives and tax breaks and loan benefits and concessional import duties, etc., has been done. So what it should be in across the a 5-year or 10-year period, how it can be phased out, how to give bigger incentives in the beginning to kickstart the electric mobility adoption, and later in a phased manner phase out such incentives and subsidies. And automotive sector need to have local manufacturing and local maintenance capabilities, how to build that, auto financing, import of auto components, in particularly EV components, etc. Then main thing comes the electrical infrastructure, which is the EVSC or electric vehicle supply equipment, or which is charging station network, and electric network capacity. When one of the main things which you have seen is that when you add a electric vehicle charging station to the electricity distribution network or the low voltage network where all these cars are plugged on, and when you are going to do fast charging, there are a lot of harmonics goes back into the electrical network. It heats the cable. It hits the distribution transformer. So we have to size the equipment appropriately. If you have to put in 50 kilowatt charger in 2 or 3 of them in one location, and 3 cars are being charged on that, the DC fast charger 50 kilowatt or 100 kilowatt, the distribution transformer capacity and its implication need to be studied in detail about the harmonics it develops and the amount of heat it generates. And the situation becomes even more difficult in a distribution line where there are rooftop solar is also there. So many of the cities and countries are actively promoting rooftop PV, and rooftop PV also injects harmonics into the electrical network. So PV plus EV scenario, if you study, many places you need a huge investment in upgrading the electricity network. That costs much more than the cost of the charging station. And then what could be the ideal EV tariff structure, so that electric vehicle owners are incentivized, and at the same time the charging operation, the third parties who are coming setting up charging station, they are also getting a return on their investment. And lastly, the vehicle grid integration. So we have been advocating that vehicle to grid integration need to be done. The battery in the vehicle can actually support the grid in terms of demand supply imbalances which are going in the distribution grid. It is becoming more often because of the rooftop PV. A cloud passes, the PV generation all on a sudden dips, so the voltage dips. So such thing can be mitigated by vehicle grid integration. The batteries can be made V2G, which is not being done in most part of the world today, but the experiments in several leading research institutions around the world have seen that the shallow charging and discharging of the automobile batteries have no adverse effect on its life. Rather, in some cases we have seen the life of the battery is extended with a large number of shallow charging and discharging. So there was even a study from University of Warwick which said that this will act as a massaging effect on the battery and extend the life and performance of the battery if shallow charging and discharging is done. With that context, we have been advocating V2G in India to be made mandatory in the new cars which will be introduced here. So coming to the another domain which we have seen where the maturity need to be assessed is the EV technology, electric vehicle, the charging station, batteries, technologies, the power electronics, the R&D sector, and that is an area where we need to look at each country, how much they will depend on themselves, how much they will depend on import. And value chain integration, there again the V2G which I said, and the business models for electric vehicle charging stations. And the customer, from the customer side, what is his interest, how is he going to benefit, their capacity to pay for a electric mobility, introduction to electric mobility and other advanced services. And we have been advocating here that the three-wheelers are the ideal candidates where in all the developing countries in SAARC region, including India, there are millions of three-wheelers which are the ideal candidates for electrification to begin with in the public transportation. Here the batteries can be swapped easily. The battery sizes are 3 to 4 kilowatt hour, which two people can easily change it. So the business model which we have been advocating here is that right from our Calcutta study in 2017, we consulted a large number of stakeholders and we seen that a three-wheeler should be, electric three-wheeler should be sold without a battery. So in which case it is cheaper than the existing ICE based three-wheeler. So a three-wheeler is sold without a battery, and he will be every day renting a battery from a large battery leasing agency in a city. Every city can have 1 or 2 or more battery leasing agency who will own the batteries, which they will charge in industrial grade charging stations, and they will truck it on smaller vehicle to points of three-wheeler concentration, different points where large number of three-wheelers will be there. They will truck the charge batteries. Whoever want to change it, the three-wheeler fellows will come and change it, and the used batteries will be taken back to the charging station. So this is some very interesting model. Today, if you look at it, particularly in India, most of the three-wheeler owners, they go in the morning to a fuel station, they put 300, 200 or 300 or 500 rupee fuel and run the day, and they will make some small money, a profit. So same way, a battery, when they are a charge battery, they are leasing it on a daily basis for 200 or 300 or whatever the correct number it is. So their entry into electric mobility is cheaper than the ICE vehicle. At the same time, there is a business model which is actually now taking off. We are the first one to propose this model in 2017. Now there are companies which have come up setting up battery charging and leasing stations in outside Delhi, in Gurgaon, in West Bengal, in a couple of other places. So that is from the customer and perspective. And societal and environmental, what are the benefit, what are the incentive for the governments and civil society to promote transportation? Number one, emission reduction, shared public transportation, new job creation, etc. So Sudhasata talked about Shenzhen city, the 100% electric vehicles in Shenzhen. 2017 they have converted all the buses, 16,500 plus electric buses operated by 3 major bus companies there. And in 2018 I visited and spent a couple of days there seeing how this electric vehicle revolution has been achieved. The biggest achievement was that in 1 year, less than 1 year of public transportation made electric, 38,000 people, they abandoned their car and started taking the shared public transportation. So the beauty of an electric vehicle is that it is not only pollution free, it is vibration free, noise free. It's a complete fatigueless transport. So you, instead of driving in the morning, you fight with the rest of the drivers for every inch of road space, and when you reach your destination you struggle to find a parking lot and then go to office. By the time you are half dead. In this case, you sit in a air conditioned electric bus. All electric buses are air conditioned. The marginal cost of air conditioning in an electric bus is only 15 to 18%. So the batteries in the vehicle need to be kept in a climate controlled environment, less than 30-35 degrees centigrade. So the passenger cabin also can be air conditioned at marginal cost. So we have been all the electric buses around the world, most of them are air conditioned. So you'll be traveling in an air conditioned vehicle. You are not driving. There is no vibration. There is no noise. There is no fatigue. You arrive fresh at your work location. So in the very first year of introduction of electric buses, 100% electric buses in Shenzhen city, 38,000 people, they stopped driving their cars to office. That gives more and more space on the road for buses and other users of the bus, even including the pedestrians and the cyclists. So that is one of the major societal and environmental benefits. So we believe that post-corona scenario also people will like the shared public transport. So this model EVMM, we will be publishing that with the 1 to 5 levels of maturity and 8 of these domains, the 40 blocks into different measurable characteristics. But the beta version which we developed, we have used for the SAARC EV roadmap, which yes, Sadasata Kundu will take you through each of the country in the alphabetical order. Any question? I can still pause here and take some questions on any of the topics which we talked so far. Otherwise, we'll take the Q&A at the end of it. Over to you, SK.
Okay, sir. So thank you, sir, for this EVMM explanation. Actually, the ISGF has developed this EVMM, and we have shown you the beta version, and we have used that beta version for this development of the roadmap, which I'll be taking you through. So first, we'll just go by this, because most of the I'll just tell you that most of the SAARC countries, apart from India and partly Bhutan and some Nepal and Sri Lanka, there was not much development on the electric vehicle field. So India is one of the major country, which has done a major development compared to other SAARC countries on the electric vehicle front. So most of the recommendations which I will say will be similar to few countries, right? So for this different phases, because we have divided this recommendation into different time phases. First is 2018 to 2020. Again, this was from 2020 to 2025, and the last one is 2025 to 2030. So first, take you through the Afghanistan one, and this vision, policy, and regulatory and institutional capacity, as described in the EVMM, which is the institutional organizational structure, establishment of an EV apex body for transport planning and policy development. As this transport planning and policy development for the EV apex body means in the body, it will be from the transport department, the electric department, or the urban development department, all can form an EV apex body for transport planning and policy development. And this roadmap for incentives subsidize the import of EVs and registration on E2 and E3 wheelers, because it will be the most cheapest source, and the most of the people in SAARC countries, even in India, are using these 2 and 3 wheelers. As we saw, there is a 238 million 2-wheelers and 3-wheelers in the SAARC countries. So if we can convert those into the electric vehicle, then there will be a huge cost of savings, and this on this import of fuel and on this emission, actually GHG emission. So we are focusing for the first year. We are for the first phase, actually from 2018 to 2020. Actually, we are already in 2020. So our recommendation from that time was that we will focus mostly on the 2-wheelers and 3-wheelers in the first phase. And this then the reduced property tax for charging station installation. So suppose you can put the charging station in a property, which in India in the building premises, as I told, that guideline is there that 20% should be reserved for the parking of the parking space for the charging station installation. So in various other countries also we can do that. We can reduce the property tax also. It will help the developers, because with fewer number of electric vehicles nowadays, it will be difficult for the ROI to achieve. So reduced property tax will act as an incentive for them. Then the automotive sector, where there's the E2 wheelers to be imported from India, China, and Japan, because if there is no there's no manufacturing, you can only import, and it will be cheaper to import from India, China, but they're already in manufacturing and masses. And then the battery and charging equipment to be imported from China, India, and China for pilot projects, because these are the nearby countries who are manufacturing the charging stations. And India is also starting to manufacture the battery. Will be starting in by this year. The electrical infrastructure exploitation of 300 gigawatt RE potential and power capacity augmentation by DABS, that is the department which is handling the power for this power sector in Afghanistan, for EV charging. Afghanistan has studied that there is a lot of potential for this RE, that is the renewable energy, and we have a 300 gigawatt potential. And the power capacity augmentation, Afghanistan is also importing power. So that capacity augmentation and the connectivity from one region to other region, because from north to south and east to west connectivity needs to be there on the transmission level. So that can be utilized for the charging of the electric vehicles, and it can be harnessed for future also when the number of electric vehicles will increase. Then EV technology, the import of e-buses and e-3-wheeler from China and India, GBT, CHAdeMO, CCS2 should be adopted. This is the standards that we're talking about, GBT, CHAdeMO, and CCS2. And currently Japan and China also developed a joint standard. And this value chain integration, big business houses to use E2-wheelers and 4-wheelers, because for the current for this phase of 2018 to 2020 which we developed, it will be easier for the big business houses, the restaurants, or these hoteliers or the industries to start the deployment of EV, as it will be easier for them from the price point of view. And there will be CSR funds for the various companies that they can pool and develop that, and that use for the deployment of EV. Then customer that create awareness for the EV pilot programs and encourage the population to use the e-buses and 3-wheelers, road programs, or these what you call this customer stakeholder discussions, along with the customer discussion from the utilities who are serving those customers can also discuss about the benefits of EV, and using the EV, how much they will help them from the health point of view, sustainability point of view, price point of view, and this cost point of view in the long run. And the social and environmental organizing EV awareness program, conduct workshops and seminars. In the next phase, when we are going to the 2020-2025, there should be a development of a national EV policy guiding what should be the target for the EV implementation, and by whom what should be target, and what are the different incentives, and what are the policies, guidelines that need to be followed by the state transport utilities or the power utilities, or DABS will take the business model, take the ownership of the charging stations themselves, will follow that business model. This pilot project on e-bus and e-3-wheelers in major cities that we can do, like Kandahar and others. Roadmap for incentive, like government support for e-3-wheelers. Like in India, government has given subsidies based on this for the electric buses to the state transport utilities, and these subsidies will be linked to the performance of these buses, because how they are performing and what is the average kilometers they are covering, the performance and everything. You can do that performance link incentives, the low interest rate loans on the e-2-wheelers and 3-wheelers. In Nepal or other places, some banks are doing, I think, on the low interest loans they are giving. The government support for third-party charging station installation. Government can provide like reduced property tax and other incentives to support that, and provide land on lease. The automotive sector, the e-bus and e-3-wheeler for pilots to be imported from India, China, and Japan. Service to be provided by OEMs. These countries, like who are not manufacturing the cars or the buses, they can do the other things like the other parts of the electric vehicle, which are smaller and which are less costly, and they have the capability to build manufacture those. They can do that, and that can also help them to reduce the cost of the electric vehicles in their countries. They can import the parts and they can only assemble there. That's also a business model they can look after. This electrical infrastructure, this upgradation of electrical infrastructure in bus depots and terminals, 3-wheeler parking spaces in major cities by DABS. That's what I was saying. DABS can take up the ownership of the charging stations and develop those. EV technology, retrofitting of EV existing 3-wheelers in India also, there are some places where they have tried that retrofitting, but the benefits and the cost benefit analysis shows that it's not much more benefit. But at the beginning of where the people are not able to spend much money and do that, they can do that retrofitting. This value chain integration, there's the battery swapping model for 3-wheelers, which the president already mentioned. The battery swapping model for this 3-wheeler is one of the best feasible business model instead of buses. Battery swapping, we can go for this 3-wheelers, because we can have the 3-wheelers without battery, and we can fit the battery because the batteries are smaller in size and the capacity is also very less, and we can do that. The DABS and Ministry of Transport to set up charging stations for e-buses in bus depots. The customer government vision on EVs communicated to customer. Incentive benefits for adapting or using EV to be communicated properly to customers, like no toll on for the EVs, no toll tax or this road tax, or you can say reduce road tax, or you can do the registration fees, and we can have a special parking for these. And the social environmental e-buses and commercial taxi fleets can also provide opportunity to the existing workforce by providing them adequate training. So you can create job opportunities also by providing the EVMM skills, operational skills for these buses and the 3-wheelers, which they can take up the local population. Now for the 25 to 2030 vision, policy and regulatory and institutional capacity. So that is the mandated EV zones in certain city centers, government offices, embassies, major market areas, EV addition city targets. So we can in the next we can do that, but you can put the targets we can do so that people can go in a specific direction to achieve those targets. There is subsidized registration fees for the 1 year, duty-free import of plant and machinery for setting up assembly units, the setting up of small assembly units for 2-wheelers and 3-wheelers. So what I was saying that that we need to go step by step. First, we do that import, bring that popularity of EVs among the public, provide do awareness campaigns, and let people start to adopt that. And at the start, we can help the big business houses and industries to adopt those who are less sensitive to cost and price. So we can do that, and then again we can move step by step and do create the assembling units or import plants and machinery for developing the assembling units. And we can do the improvements in power qualities of deployment of technologies like harmonic filters, static compensators, which we were previously telling you that harmonics, PV and EV are the very we did a study in Bangalore. We're currently doing a study in Bangalore where these harmonics are being taken care of. We are doing the load flow study where this impact of harmonics is being evaluated. So that can be done. And the EV technology, because EV is a non-linear load, so it will have impact on the grid network on this harmonic side. And the EV technology, government and international research labs, technology institutes, private companies to work on optimization of lithium extraction process. Although it is a far-fetched thing, because in Afghanistan it's very difficult currently, considering the situation, to do such an extraction process. But it can be taken up in future until at least 10-15 years after. This value chain integration, pilot project stations, charging stations should be established at prominent bus routes, areas having high 3-wheeler concentration, So charging stations or battery swapping for three-wheelers, and we can do that for the buses for the charging stations. TOU pricing and its benefit to customer must be displaced, but not TOU. If TOD pricing is also there, then also it will help the customers to use their benefit to charge the EVs, and they can receive the this tariff benefits. And the social and environmental deployment goals by the government to help bring electricity in the remote areas. Obviously, with electric vehicles adoption, you need to extend their network connections, and we can need to extend the reach of the electricity to all the villages where the three-wheelers will be, not three-wheelers, electric vehicle will be used. So that is that also can help to boost this 24/7 electricity supply or the reaching of the electricity in the remote areas. Then for the Bangladesh, so as already the time is already getting finished, so I will not go much in detail on all the countries, but if you can, it is already in our report, so you can see that, because most of the countries are in nascent stage. Suppose some are in stage 1 or some are in stage 2, not more than that. So we can have this. Hello.
Hi. So basically, you can take your time to explain these recommendations, country-wise recommendations. It's not a problem. The session which we had organized for the feedback. So basically, this is particularly relevant for that session, and this will be useful. So I suggest you continue with this country-wise suggestions, and just try to take like 5 to 6 minutes for each country.
Okay, sure. Thank you. So with Bangladesh, like in 2020, as so I'll be just highlighting the major points that we have for this different phases, which in different domains, which I've highlighted here, which I've mentioned. But I'll highlight the major points from there. Like in vision, policy, and regulatory, we have launched nationwide EV mission along with the set of policies, because Bangladesh is far ahead in stage of policy making and regulations, like Afghanistan. So they can do that on the policy making and launch nationwide EV mission, because already they have they're already importing cars from Japan, or this used cars from Japan. So they can do that, and their three-wheelers and others. And there is the three-wheelers manufacturing is also, I think they're doing the assembling and other things in Bangladesh. So it will be easier for them. So in the near term, like in 2020, 2018, 2020, we mentioned that they launched nationwide EV mission along with a set of policies and guidelines for three-wheelers. And then the roadmap for incentives, subsidize the import duty on EVs and registrations. So you can do those import duties because they're already importing, so it will help them benefit. They're importing from India or importing from Japan or China, so it will help them. And the reduced property tax for three-wheeler manufacturing and assemblers, because three-wheeler is much more in use in Bangladesh, so they can do that. In automotive sector, e-rickshaws and two-wheelers to be locally produced and assembled. This is already there are plans, I think, for two-wheelers. So e-rickshaws and two-wheelers can be manufactured or assembled in Bangladesh in a very quick time. And this electrical infrastructure, power quality, peak demand, and DT assessment discount in other areas for EV charging. Bangladesh has already transitioned the what's called the electricity sector, and the electricity sector is doing well nowadays, with generation also getting from the gas sector. It is being transited to coal and other things to do that for the energy security. That transit means they're already moving from this only gas to others, coal and others, imported coal and this LNG. So, and the distribution side also, they are doing a lot of improvement by DPDC and other organizations and other distribution companies. So electrical infrastructure, they can do this improvement right now on the power quality and peak demand and DT assessment by DISCOM, so that if any capacity is available in the existing DTs, the distribution transformers that can be used for the charging, this EV technology and this batteries used in three-wheelers to be upgraded to lithium-ion batteries, because there are totos or e-rickshaws are more common in India, Bangladesh, and other areas, Nepal. So there they can use this lithium-ion batteries instead of the currently used lead acid. And this value chain integration, the government buildings and offices to install the charging stations in the major utilities like BPDB, REB, etc., to invest in public charging. BPDB has already taken care of all the electricity, they taking care of the discoms and others in power procurement and things. So BPDB can take this ownership, or the REB, etc., can also, REB can also want to invest in public charging stations and EV fleet infrastructure. So this customer, the incentive and benefits of EV is passed on to customer. The R&D on the vehicle usage pattern to figure out the load curve for a particular day or for by an EV sale. So these type of things can be done, and the TOD can be developed by the usage of, by seeing the charging patterns, and when the load will get high, and means what the peak demand will be there due to charging of EVs. if there is shifting in the demand. So this can be done, and the customers can take the benefits of time of day or time of use tariff to avoid the high cost of charging and usage. The social and environmental, the organizing EV awareness programs, conduct workshops and seminars. Then for 2020-2025, this BRTA to define guidelines and licensing driving norms, operation rules to streamline the EV adoption process. So there you can, the road transport and others, they can do that. If there is any BRT or something for the buses, they can allocate it for the e-buses, and they can also define some guidelines and the licensing norms, and there is single window clearance for the electric vehicle thing. The roadmap for incentive, that's tax-free or reduced tax for profit repatriation, because if foreign companies coming and investing in the EV thing, and this, the profit repatriation should be there, and this tax-free repatriation should be there, so that they can this will attract the foreign investors. The reduced tariff for passenger using electric water transport, because water transport is one of the major transport in Bangladesh. So reduced tariff can be there if they're using the solar boats. Bangladesh is already using solar boats, I think, and they can transit to electric boats using the solar. They can do it instead of the fuel engines and then IC. And then automotive sector, this servicing for the electric ferries and charging stations to be provided by OEMs for initial years, local manufacturing through 100% foreign collaboration, and this FDI and EV parts. So electrical infrastructure upgradation and power quality improvement in bus depots. So when you are putting up charging stations in bus depots like 10 or 20, you need to develop a on-site substation for that, and dedicated 11 kV feeder, dedicated transformer based on this availability of existing transformers. So a new transformer and others, the cabling and everything needs to be done. So that can be done, that can be taken up in the electrical infrastructure upgradation, where the charging stations will be built in the bus depots. The EV technology, the standards in India and Japan adopted for interoperability. I think most of the cars in Bangladesh are from India and Japan, so CHAdeMO, and if India is developing a combination of CCS2 and CHAdeMO, then that can also be adopted. There's value chain integration, PPP model with private parking owners or service providers for OEMs. So PPP model can also be developed with government facilitating with in the spaces and other things. And these private owners can come up and develop the charging stations. The bundle EVSC as a mandatory in building codes, which they have done with the 20% of parking space reserved for the charging stations. And customer TOE pricing for EV to be communicated to customers. This time of use pricing, the subsidized EVs and the EV and commercial taxes for opportunity existing workforce. Workforce can mostly on this maintenance side, and this can be done. And this Bangladesh roadmap for 2025-2030. So here also, if you can see that we're going phase by phase. First on that, if the country is on a higher scale in some of the aspects, like in any of the domains that we explained in the EVMM, there are 6. There are already 8 domains, and each of the domains there is we can levels of maturity is there. So based on that maturity, we are develop the recommendations in phase wise. So you can see, like in Afghanistan, which is in the 3rd phase, in Bangladesh, it may be on the 1st or the 2nd phase because of the developments of the maturity level in few of the domains. So like in vision policy, here it is the mandatory electrification of private taxi fleets, and the grid code and distribution code guidelines must be updated for vehicle to grid integration. This grid code and distribution code guidelines can be done, but vehicle to grid integration can be done later on, and pilots should be started in this phase. This roadmap for incentive, the reduced property tax for residential complexes in few years for EV charging installations. So the promotion of battery recycling through industry through tax-free income, because in India, in Tata currently started the battery recycling at a small scale, I think. So this in battery recycling can be adopted by Bangladesh also. And this property tax for residential complex in few years for EV charging installation, we can do that. The automotive sector, local manufacturing units can joint venture with the foreign companies, because in the previous phase they're working as an assembling unit. Now they can collaborate with the foreign companies for the development manufacturing. 100% FDI in the lithium ion. Then the upgradation expense can be shared by OEMs on third-party service providers for charging stations. Grid asset modernization for implementing V2G solutions. So if the pilot, we should be well prepared beforehand. So we can do the smart grid solutions, so that we can the remote monitoring and control, and the charging stations and the utilities can do that. Similarly, on this automotive sector, also in India, also this FDI is coming for this lithium ion manufacturing, that can also be taken up by Bangladesh. EV technology, EV testing and certification center. Then the value chain, the certification intentions, because you need the EVs need to be tested and certified along with the charging stations and all that need to be. International certification centers are there. Some national centers can be developed, standards can be developed, and that can be certified. This value chain integration, dedicated fleet operators like e-buses can invest themselves by bringing third party to invest in charging stations. The customers are engaged in prosumer programs of V2G integration and pilot basis. That customers only in the pilot areas where the V2G can be done in areas like Dhaka, there can be the customers can be brought in to get the benefits of V2G and how that aggregator model can be developed, collecting all the electric vehicles and making it as a source of energy. So advanced booking on parking lots through e-booking based on time and amount of charge in major cities, that can be done. In many areas currently this is being done through apps. So that can be done. And then social environmental EV manufacturing help in job creation. Usage of electric board and launches will negate the chances of oil spills from boats, because in recent study what we are mentioning that we did a study in the Sundarban landscape. This diesel boats or the boats that are being used are 3 times more harmful or emitting 3 times more emission, GHG emission doing than this 3-wheelers actually, which are running on IC engines. So you can see that these boats are doing much more pollution than these IC 3-wheelers, and the chances of oil spills, these are also there, which are also creating water pollution. Now coming to Bhutan, so Bhutan has already, I think, done a good job on the implementation of charging stations, and under UNDP project, I think they have created some charging station we run around Thimphu, and the electric cars are also running, I think, some of the. So vision and policy, regulatory institution capacity, we can see the city target for electrification of public transportation. BPC as implementing agency for public buses, as Bhutan is and Thimphu is a small country, and Thimphu BPC can take hold of this implementing as an implementing agency of the public buses electrification. And the vehicles normally used in Bhutan are this cars, that four-wheelers and two-wheelers can be also be electrified. And the charging station implementation BPC is currently taking up, so BPC can take up that ownership and start doing that. And this exempt import and custom duties on EVs and EV components, the EV should be given a upper hand in terms of this parking, and they can be given reduced and they can be given incentives or these waiving off of the toll tax and others. The automotive sectors, they encourage EV assembly units for mainly 2 and 4. EV assembly units can be done for the 2-wheeler, 4-wheelers, and the electrical infrastructure BPC to assess the availability power and spare capacity entities in areas having potential for high charging station implementation. So BPC can do that. This DTC distribution transformers, they can assess the distribution transformer existing capacity and how much being utilized and what time frame they are being utilized during a day, and so that they can structure the tariff in a way that time during which that there is lesser utilization of the distribution transformer, that time that people should do charging to avoid a higher cost in other times for the charging. So that can be done, and they will start utilized because Bhutan has ample amount of hydropower and electricity being generated. They're mostly exporting to India and are planning to Bangladesh also. The Bhutan has ample power capacity that they can utilize for the EV charging and do the electrification. The EV technology upgradation should be done in the battery segment with latest lithium-ion batteries. So lithium-ion batteries thing should be there. And this value chain integration, BPC is to set up the public charging station and dedicated grid infrastructure that BPC can do and start its own EV infrastructure on that. Tourism Council of Bhutan can plan for developing charging stations in various tourist places, because Bhutan is a mostly tourist place, and Bhutan Tourism Council is very strong, and they can plan for developing the charging stations in far places from Thimphu. And the customers, the government vision and target, and they can also, this Bhutan Tourism Council can also mandate the use of EVs, electric vehicle for EV 4-wheelers for this tourist movement. And the customers, the government vision and target for EVs communicated to the customers, and this organizing EV awareness program. In this Bhutan EV roadmap for this 2020-2025, the capex for EV and subsidies can be given on the capex, the reduced electricity tariff for charging, road tax for electric 4-wheelers. Maybe there's the waiving of the tourists who are traveling in this 4-wheelers for this site visits and sightseeings and other tourist spots. That can be the entry ticket can be reduced. entry fees can be reduced. The automotive sector, the servicing facilities of EVs and charging stations to be provided by OEMs. Electrical infrastructure upgradation taken by BPC will be taken care of by BPC, and grid asset modernization. This value chain integration, or I can say the major cities and tourist places can prioritize the installation of charging stations. TOU pricing or TOD pricing can be done and can be taken up and communicated to customers. EV deployment and the local workforce may be skilled to maybe given training to develop the O&M skills that can help in job creations. For 25 to 2030, the this guidelines for third-party charging stations. The first the government is taking up, then commercialize the charging stations in the final phase and do the third-party charging stations, grid code and distribution code development, for developing service factoring, to the PPP with foreign countries. We are initiating on the customers are engaged in the prosumer programs, and thereby the customers can become a producer and B2G, where they can use the EV energy into the grid, where they can feed the EV energy into the grid. And then the advanced services for customers like door-to-door service for car charging that can be developed, because being a smaller city, and then it's a very small city, so people can do that facility, and advanced services for customers like door-to-door service for charging, like someone can come and tell some company can come and ask and take the EVs in the night, and they can give it to the customer back by charging the whole of EV. Means that EVs can be charged throughout the night at any company's premises, and the service provider can take the car from the already front, and there are already 6,000 electric.
Yes. Sir, there is
Your voice is not clear if you are speaking to me. Otherwise, hello.
Yeah, yes, I'm speaking to you. Your voice is.
Question is there?
No, there is no question. There is a distortion in your voice. We cannot.
Sir, your voice.
Hello.
Hello.
Yes.
Sir, your voice is not clear. I'm not getting it.
Sir, can you hear me right now?
I can hear you.
Yeah. So there is a distortion in your voice from last 1 minute, 1 or 2 minutes. So can you repeat what you say?
Okay,
repeat
sure.
Thank you.
In Bhutan, actually, as described in the last phase, this 2025 to 2030 roadmap for Bhutan, where we have prepared these recommendations, that the guidelines for the third-party charging stations, because first it was taken by BPC. Now we can move it to the third-party charging stations. The testing facilities can be developed by electrical infrastructure, by the grid asset modernization for implementing B2G solution that BPC can think of for doing a pilot. EV technology on the EV design, research and development can be carried out. And this value chain integration bundle EVSM, EVSE, means the charging stations, EV charging stations, or we already call it electric vehicle supply equipment, as a mandatory in new buildings. Dedicated fleet operators for e-buses can invest by themselves or bring third party to invest. Customers can also be made aware of this B2G integration. Advanced services for customers like door-to-door service, which I was explaining, like that the customer being a small city, Thimphu, customers, any company can provide charging to the customers for the overnight charging. Suppose a company is there, it can take the car from the customers in the night, get it charged throughout the night, and deliver it to the customer next day morning. So that type of services can be thought of, and the social and environmental third-party service providing of charging stations will lead to job creation and for the people. Now coming to the EV roadmap, and India has already taken so many steps, and for more than 6,000 electric buses by the government have been sanctioned by the DHA Department of Heavy Industries have sanctioned subsidies for that for the state transport utilities, and also these electric two-wheelers and three-wheelers are already taking the development is taking place, so that the deployment is already getting accelerated in these areas. So GST roadmap for incentive, the GST rate should be rationalized on EVs and EV components, reduced fare for e-buses users, and reduced EV charging tariff. The local manufacturing for EVs and EV batteries to JVs with companies like Europe, China, and Japan in India is already happening right now. The DISCOMs to assess the availability of spare capacity in DCs. We already did a study in Calcutta where assess the availability of spare capacity in DTs and utilize and suggested recommendation how to utilize those capacity, create dynamic tariff structure. Thus EV technology retrofitting of the older EV models with new technology, and this in some of the companies are doing that. In case of electric trucks also they're doing that. The value chain integration, government buildings and offices to electrify their vehicles and install charging stations in their premises. Government vision and target for EVs as well as TOU pricing benefit communicate to customers. We already did that for TOU. Research on the vehicle usage pattern to figure out the load curve for the EV sale. That they were EV sale organizing EV awareness programs, conduct workshops. 2020-2025, the public transport electrification, smart city mission, because in already this India is a smart city mission, the public transport electrification can be done in every smart cities. Grid code and distribution code, reduced tax on profit repatriation. Electrical infrastructure, we are also working on that. ISGF is also helping this Bangalore Electric Supply Company, just previously mentioned by President, that we're doing that, and we're developing those. We are identifying the strategic locations by doing load flow studies in the various feeders where the charging stations need to be connected, whether they're EV, and doing the harmonic analysis and other things. The value chain integration, the state transport authorities to install charging stations on ferry guards for boats. In Kerala also, this electrification of ferries are taking place. The pilot projects for water transport free electrification already taking place. Then customers, then social environmental, two-wheelers and three-wheelers manufacturing. 2025 to 2030, this India, the vision, policy, regulatory, institutional. We can go for this government to provide guidelines for battery recycling, this mandatory full electrification of public bus fleets, the battery manufacturing to 100% FDI and JV with local companies already being started in India. It will, the recommendation is for full-fledged develop manufacturing of that. This EV technology, R&D on battery and battery recycling, value chain integration. So dedicated trade offers like e-buses and e4-wheelers invest themselves by bringing third party to invest in charging stations. Currently, they're only charging station developed by third party, not by third party, because the ROI is not achievable right now. But in 2025, by 2030, the ROI will be much higher, and that time the third party investment will take place. Will be taking place at a faster rate. The customer also engaged in prosumer programs, the V2G integration on pilot basis. The usage of electric boats and launches will negate the chances of oil spills from boats. This Maldives roadmap for this AV, as Maldives and most of the things are water transport. The thing given focus has been given on the water transport apart from the road transport. So exempt from the custom duty on EVs and EV components, the EV testing certifications, DISCOMs to assess the availability of power and spare. These are the normal, because we suggested these things because these are the normal in the near future. We can do. These are the steps that we can take up in the near future. Easier for the countries to take up those steps. So without going much into complexity, we have recommended the steps for the near future. And as we move ahead in 25, 2030, then we have recommended steps that takes time to develop or achieve. This all the incentives and benefits for writing or using an EV to be communicated properly. By 25, what we did is the mandate the use of electric 2- and 4-wheelers for vehicle rental companies, resort and hotels. Then subsidy on low interest loan from banks for small fishermen or purchasing electric boats. As the number of boats are more, so we have focused on that. This assembling units for EVs and e-boats mainly to be set up on JV model, as there are various there are boat manufacturers, so they can use they can move to the electric boat manufacturing. on this power quality improvement. There are microgrids in various islands in Maldives, and they're mostly they're also relying on the renewables. That renewable potential is there, so that can be utilized for that. The EV2 and four-wheeler testing and certification center can be developed at a later stage. Bundle EVSE as a mandatory, so building codes, time of use pricing and its benefits, EV deployment to the country existing workforce. 2030, actually, vision, policy, and regulatory institutional capacity, mandate electrification of boats, duty-free import of plant and machinery. Then automotive sector promote local manufacturing, implementation of charging stations by supermarkets, MEA technocrats, private parking owners and service providers can implement public charging stations, that is third party, moving to third party. Customers are engaged in prosumer programs through V2G, and this job creation is there. So actually for this, and then going to the Nepal, and this is for Nepal also, we can take into account the this importance of the hydropower that is being there, so it will help them to electrify that. And also the Nepal is also importing fuels from India and everything in India, and that there is a was a shortage during there some problem. There is a border a few years back actually, there's some problem in the border, and there's a stoppage from the import of fuels to Nepal, and there was a hue and cry in the Nepal, and the prices shoots up like anything that time. So that things can be avoided when you have something in abundant capacity like hydropower, which is abundant in Nepal, that can be used for electrification, and that electrification can be used to transform the transport sector into the electrical transport sector. So in this for the Nepal, in the near term, we have given some of the recommendations which are given to other countries also, to exemption of import and custom duty on EVs and EV components, because Nepal is also importing cars. So dictate the EV adoption target to cities, because Nepal has shown some aggressive steps for this conversion from this fuel-based vehicles to the sustainable vehicles like solar-based e-rickshaws and all. Already they did that, three-wheelers. So E3-wheelers to be assembled and imported parts from India or China, that is come to assess the availability. NEA is doing various things on study on EV. I think this Nepal engineering company is doing a study, and they're already figuring out how to improve the electrical infrastructure, the value chain integration, this government buildings and offices to electrify their vehicles, like like the Ministry of Energy or this NEA, Nepal Electricity Authority. They can do that. NEA can take up for the initial level. NEA can take up the investment burden for this charging, setting up charging infrastructure, and then customers, the government vision and target for EVs and communicated to customers. The tourism will flourish by projecting areas as carbon neutral with EVs. Nepal is also a tourist destination. There's big hotels, the restaurants on the, what you can call this, industries, Nepal industries, and they can take up these EVs and they can use it for the tourist purpose. The tourism council can also take up the responsibility of allocating this E four-wheelers, electric four-wheelers for the movement of the tourists. And this EV roadmap 25, they're also one step ahead. They can go for the separate EV tariff or TOU pricing for EVs. There is servicing facility for charging stations to be provided by OEMs, 100% local manufacturing units to be promoted for two-wheeler or three-wheelers, electrical infrastructure that needs to be bus depots and terminals and parking lots by NEA for installation of charging stations. This Nepal engineering company to enhance charging standards and communications that they can do, because they're already doing a research on electric vehicles, so they can do that. Time of use pricing and its benefits to the customers must be displayed and to make them aware of their benefits. EV deployment will provide opportunity to the training and OEM skills. Similarly, by 2030, they can go to the for EV. They can go for local capacity development on O&M for charging stations. They can go for grid asset modernization with smart grid and other technologies. They can do and by 2020 and by 2025, they should have done some studies also on that. And based on that studies, they should go for 2030 grid modernization, then electrical infrastructure upgradation for monorail implementation, because monorail is already being talked of in Kathmandu. the value chain integration, the transition of private cars and electric fleets. Customers are engaged in consumer programs of V2G integration. Deployment goals by government will also help to bring electricity in remote areas. Then going to Pakistan, the Pakistan also taken some initial steps towards putting up charging stations in some places, and SAARC Energy Center is also, I think, being facilitating in that, and they're also taking up studies to do that. Then the vision, policy, and regulatory in that we can go the EV cell creation with the concerned ministry, pilot e-bus fleet project in Karachi, Lahore, Islamabad, and the major cities. Roadmap for incentive, the exempt import and custom duty on EVs and EV components. Even the SAARC Energy Center can buy EVs and start moving in EVs. And this automotive sector, the automotive testing and training center to approve the 2-wheelers and 3-wheelers, the DISCOM to assess the spare capacity. And here, this on the EV technology, Pakistan can has BMW charge now charging stations which follow CCS standards. And as most of the vehicles, the Japanese and Chinese and Pakistan can use CHAdeMO or GBT, and you can use this current standards which is being jointly found by CHAdeMO and this Japan and China. By 2025, this public bus fleet electrification for intra-city transfers or installation of charging stations in depots and terminals that can happen in major cities. Local manufacturing units for 2-wheelers and 3-wheelers can be taken up easily in Pakistan. The electrical infrastructure in bus depots and terminals by DISCOMs to be upgraded. This automotive testing and training center to validate and certify. The TOE pricing, time of use pricing by this in major cities by the Lahore DISCOM, Karachi, and others, they can take up that. It's more advanced DISCOMs like Lahore and Karachi. And then the social environmental, the EV deployment, mainly the buses and commercial taxis fleets. In Pakistan for 2030, that the distribution code and grid core for vehicle to grid integration, at least a pilot can be thought of. If EVs are already in place by that time, then when sufficient number of EVs are already in place, then automotive sector, the servicing facility for charging stations, implementation of charging station by supermarkets, big retailers, grid asset modernizations for two-way communication. This Pakistan Automobile Institute, Technocrat, and EV associations to decide on interoperability charging standards or which standards to follow from other countries that they can decide on. This value chain integration, dedicated fleet operators, this customers, advanced booking on parking slots through e-booking based on time and amount of charge required. That can be done in major cities where the number of 4-wheelers are much more, 2-wheelers and 4-wheelers, and adoption of electric 2-wheelers and 4-wheelers are much more. The social environmental deployment goals to help bring electricity in remote areas. Then lastly, we'll come to Sri Lanka. There also you have to keep a balance between the road transport and water transport also, and others that must be and this nationwide EV policy, and Sri Lanka has already taken some steps much before on the hybrid vehicles. So on that, keeping that in mind, and there are charging stations also. So keeping that in mind, we develop the recommendations and vision policy, regulatory and institutional capacity, e-basis majorly intra-city buses project in major cities that can be done in Kandy or that can be done in Colombo. Exempt import duty on EVs and EV components, subsidized parking charges for EVs, DISCOMs to assess the supply and availability of spare capacity entities that can be done for the pilot projects on specific areas in Colombo. EV technology for 2-wheelers to be upgraded in design battery capacity. With already manufacturing that. CEP with SLTMP to invest in charging stations along electricity board can do that, along with in the initial phase. And then LECO also can help. And then on this customer on the TOU pricing and benefits, the organization EV awareness program, as already in Colombo, the hybrid vehicles are already people know about hybrid vehicles throughout Sri Lanka. So EV will be easy to make people aware of the EV thing. Then vision, policy, and regulatory for the 2025. The roadmap for incentive, the tax for reduced road tax for E4-wheeler commercial fleets. As commercial fleets are coming up nowadays, and EV and Sri Lanka is also being a tourist destination. A lot of 4-wheelers are operating on this hybrid vehicles or these IC-based vehicles. So that can converted to EVs. Easily.
Excuse me, Mr. Guru, we are having difficulty hearing your voice. There's a distortion coming. Can you please check your volume?
Hello,
Hello?
you can hear me?
Yes, now it's better. Previously, you were having distortion in your voice.
Okay, for how many minutes so that I can go back?
Just last 1 minute, we were having distortion.
Yes?
We were having distortion for the last 1 minute.
So I was discussing about Sri Lanka. Last one, right? This one?
Yes, please continue for the Sri Lanka roadmap.
Okay, sure. So for the Sri Lanka roadmap, what I was saying is Sri Lanka has already been taking steps, taken steps on this high usage of hybrid vehicles, and various tourist vehicles are hybrid in Sri Lanka, and they also doing much on the charging stations. So when there are some in this adoption of electric vehicle in Sri Lanka. For that, we have started the vision policy and regulatory, and that electric buses, majorly in Colombo and other cities like Kandy, that can be adopted. The subsidized parking charges for EVs, because already they have started adopting EVs on the mainly on four-wheelers. And the three-wheelers, discoms to assess the supply and availability of spare capacity, entities, and power supply from renewables, because Sri Lanka renewable has a very huge impact on the power sector, and that they have already developed a roadmap for utilizing the renewables or implementation of renewable technologies in Sri Lanka. Then the EV technology, technology for two-wheelers can be upgraded. That has already been there. They're manufacturing. Then LECO and CEV can take up the initial phase, take up the investment burden to set up charging stations. The customers and this TOE pricing and benefits, the social, environmental, this job EV awareness programs. That will be easier to aware the consumers in Sri Lanka, customers in Sri Lanka to make them aware of the EV thing, because they're already been using the hybrid vehicles. The EV roadmap for 2020-2025, where we have taken care of this fisherman boats also, means waterways also, because most of the many of the Sri Lankan transport consists of the ports in the waterways and water transport, and the fisherman boats have been given much importance in Sri Lanka because it's one of the major activities in Sri Lanka. So this we have given such importance to that also, and in our roadmap we have included that. For this public bus fleet electrification of three-wheeler inland water transport. And inland water transport, we mainly recommend on the fisherman boats. So reduced road tax for the four-wheeler commercial fleet, then 100% local manufacturing to be set up for E2-wheelers, which is already being there right now. So make it go for 100% local manufacturing, upgradation, improvement in power quality by Lake 1. CB, PUSCL with the utility, they can technocrats and EV association to enhance the charging standards and communication protocols, what charging standards they want to follow and how to adapt that in Sri Lankan way, in Sri Lankan scenario. Then the value chain integration, transport board along with the distribution utility can set up charging stations for inland water transport in Colombo, advanced booking of parking slots through e-booking based on time. Then on the 2030, they can mandatory electrification of private taxi fleets. Then the grid code and distribution code guidelines to add B2G, grid asset modernization for facilitating two-way communication. Customs are engaged in prosumer programs, R&D on EV design and battery recycling, then usage of electric boats for inland transport and fishing, thereby reducing water pollution. So with this, we have completed that recommendation section on the EV roadmap for various SAARC countries. Just I want to mention that we should understand that we should move step by step, and the recommendation that we have given in the phase-wise manner for each of the countries. starting the government should take the certain burden by themselves with deployment of more number of EVs. Private sector can come, as there will be achievable ROI, return on investment on the charging stations and other EV manufacturing and everything. Consumers can take benefits, and by the discoms should upgrade the network infrastructure, and with different very dynamic tariff like TOU, time of use or time of day, customers can take benefit of that pricing mechanisms, and also take part in B2G in a later stage after a few years, where they can react to the price signals and can feed the electrical energy stored in the battery of the EVs into the grid. So, and with each step that is mentioned in the recommendations, ISGF can help each countries or any institutions with each of these steps, as we are doing a lot of projects on EV and smart grid and renewables and designing of tariffs. So ISGF will be eager to help you on that. So over to Mr. Umar.
Thank you so much, Mr. Kundu, for a very comprehensive overview of the roadmaps for each of the SAARC member states. We will be quickly moving towards the question and answer as well as the feedback session. So we'll be combining them together. I'll start reading out the questions, and I would request the team from India Smart Forum, including Mr. Reji Kumar Pillai, if they would like to answer them one by one. So the first question is from Mr. Bulan Siddiqui. He's asking, what is the share of transport sector of India in the greenhouse gas emissions?
Share of transport sector in India in greenhouse gas emissions, I think it's near about within the range of 20%.
All right. We have a second question from Bhutan. It says electric vehicles in plain areas may be much more economical and easier to implement than in hilly areas. So he's asking your opinion, and Mr. Reji Kumar Pillai's opinion. Do you think countries like Nepal and Bhutan and other hilly regions should be promoting electric vehicles?
Muted, I think. The voice is not coming.
Yeah, Mr. Reji is self-muted.
Yeah, now I am unmuted. I believe you can hear me.
Yes, we can hear you.
Yeah, absolutely. So these countries are importing refined petroleum products from different places, which is very expensive, and transported all the way through India to Bhutan and Nepal. It's for them, the life cycle cost of electric vehicles already is much cheaper than the IC waste vehicle, and the building infrastructure is in a phased manner over the next 3 to 5 years is possible. So if you take any of the cities where, Bhutan doesn't have much of a population and much of a traffic congestion, but if you take Nepal, you will find a large number of three-wheelers and two-wheelers, which all can straight away go into electric without much of a public infrastructure to be created. So, and the case of buses, the charging station for the buses will be installed in the bus depots or in the bus stations, and that will be operated by the bus operating companies. So there again, there are no major challenges. Only when it comes to private car, which in any of these countries not more than 5 to 10% of the total the vehicle stock, that is where you really need public charging stations. And we all being democracies in SAARC, it will be very difficult for the government to tell public that you should buy electric car or you should buy diesel car or petrol car. So it will take its own time. When people will feel comfortable, when they see it is cost effective, they will buy it on their own choice of the and also the models, different models available in the country. But what we have been advocating is that government can say all taxis will be electric from say 2022. All the new three-wheelers will be electric from 2022, or all new two-wheelers sold in India will be, or in any country will be electric from 2025, or all school buses will be electric from 2024. Those kind of time-based, very brave policy interventions, if they do, automatically things get changed, and then infrastructure get created, and people will, I mean, private vehicles also will come. They can very clearly say that all government vehicles will be electric. In Government of India already started that program. 10% of the electric vehicles will be electric. And one government company called Energy Efficiency Services, they have been buying electric vehicles and leasing to different government agencies. So next they could do is that all tourist places like Taj Mahal and Red Fort and all those great places, or city center of the city in many of the big towns, they can say that within the city center or the tourist places or religious places, we will not allow regular vehicle, only electric vehicle can come. So people have to park outside and take a public transport which is electric and come to the center of the city or to the tourist places. So when you do such phased intervention, policy interventions, automatically it gets the change happens. All on a sudden, we will not be able to create infrastructure and tell all vehicles to be replaced. So most of the countries are saying that beyond 2030, there will be no sale of ICE engine-based vehicles. In a phased manner, from 2024 or 25 to 30, all new vehicles are going to be, the public transportation vehicles are going to be electric.
All right, thank you so much. Next question is from Mr. Ashraf Hussain from Bangladesh. He's asking you to elaborate a little bit more about the integration of rooftop PV and electric EV. Well, this is a very extensive subject, to be honest, so I would request you to elaborate it in like as less time as possible, because we then have to move on to other questions as well.
No, I didn't get it. Elaborate with EV versus?
He requested to elaborate the integration of rooftop PV and EV. I think this was regarding the model which you suggested.
Yeah. No, we have been talking on this and we are trying to do some modeling studies also. See, the rooftop PV, mostly 99% of the rooftop PV are connected to the low voltage network. Same is the case with electric vehicle. The charging stations are all on the low voltage network. So take the case of a feeder where there is the fair amount of rooftop PV is there. Say the distribution transformer 630 kVA distribution transformer giving 3 feeder, one street where there are 50 or 60 houses, of which there are about 100 kilowatt of rooftop PV are there, and there are also 10 electric vehicles people are plugged onto the vehicle. So basically V2G should happen on AC charging. So AC type 2 charging, we should allow V2G to happen. This is exactly like an inverter kind of a function. So the vehicle you charge it, you plug onto the AC charger, you program it that when the power on the electricity is cheap on the grid, you buy it, and when the price of the electricity is more than X rupees or X cents, you sell it, but keep enough to drive 20 kilometer or 50 kilometer. But also for V2G function, between 70% to 90% charging, discharging 70 to 90 or 90 to 60, up to 60 is fine. Any number of times grid support required. Whenever a signal comes from the grid operator, you pump electricity back to the grid, and after that signal goes, again you buy from the charge from the grid and go back up to the 90% or 95%. So this is something which can actually support the grid, and the voltage smoothing can happen. If you look at any output of a PV rooftop or a large PV plant, over the day you will find a very smooth curve going up in the morning, peaking afternoon, and then coming down. But actually, if you look at every minute PV generation, you can see huge spikes, up and down, huge spikes. So that today it doesn't matter, because in most of the feeders, rooftop PV is not even more than 5% or 10% of the load. But then rooftop PV or solar or renewable becomes 30% or 40% of the total capacity on a feeder. The voltage will be dancing every second. So to smoothen that, one of the cheapest investment is integration of the vehicle with the low voltage grid. It's called VGI or V2G, and this is something which are technologies which are already evolved. It's only the main resistance of this is from the electric vehicle manufacturers. They are not allowing it because they have a warranty, back-to-back warranty from the battery manufacturer, who has given him 5,000 cycle or 3,000 cycle. So in a day 10 times if you do charging discharging, that warranty goes. So that is where we have to work with them to get that mandatory, that 90% to 60% is not considered as a cycle. It's considered as a V2G event during the day, and that is not going to have any adverse effect on the life of the battery. Thank you.
Thank you very much. Just my question subsequent to this question is that what would be the possible degradation of the battery in percentage terms if this cycle V2G cycle is carried out? Is there any quantified research on this one?
Okay, I'll tell you. Many universities and research laboratories where they have done V2G in this way, the shallow charging and discharging, there is no adverse impact on the battery. In fact, a couple of years ago, when I was at University of San Diego, UCSD, they had 2 Nissan Leaf. At that point in time, they had already completed 7 years of V2G services. So 2011 to 2018, and that 7 years of time, the one vehicle they put it on V2G, one vehicle they had not put it on V2G. So the vehicle which was on V2G, the battery was still healthy and it was in service. The one which was not on V2G, they had to replace the battery after 6 years. So, and there are many other studies from many other universities and research labs. They all says that if you do V2G in a responsible manner, there is no adverse impact on the life of the battery.
All right, thank you so much. There is a question from Mr. Huyen from Bhutan. He's asking that Bhutan initiated EV program since 10 years ago. However, it has failed to capture the market mainly due to concerns on flying on mountainous roads and shorter mileage per charge. So, what is the current status of the technology to address such concerns?
See, 10 years ago, the batteries used to be very expensive. The size of the battery used to be small because, as I said in the beginning, in 2010, 2011, $1,100 per kilowatt hour was the cost of the battery, and the performance of the battery was also quite poor. Even those days, 2011, 2012, the best battery had the energy density of 50 watt-hour per kilogram of the weight of the battery. 1 kilogram of battery, you had 50 watt-hour. Today, that has gone beyond 200. So that a lot of improvement has happened in the material science and in the battery chemistry. So the efficiency, number of cycles, and all has gone up multiple times, whereas the price has come down by 90%. Now is the time for the electric vehicle people to adopt. It is cost effective, as I repeatedly said. If you look at about 15 years ago, in Israel, there was a company called Better Place. You can Google it, you can find the book also on Better Place. So that was way ahead of its time, when the batteries used to be $2,500 to $3,000 per megawatt hour, and the performance used to be much less. One charge would not take you even 50 kilometers. Somebody set up a electric vehicle network in the entire Israel, burning billions of dollars, and they declared bankruptcy by 2008 or 2009. In 5 years, they gone. Actually, the man who promoted was the co-founder of SAP in Germany. So he went back to Israel and he exited his stake in SAP's. He had about $2.5 billion, which he went and invested, and along with that, a lot of other investors' money. So there are early on the technology cycle, when you make such investment, yes, it's bound to have problems. Now technology is maturing and it's commercially viable in all geographies. So Bhutan should now look at it more seriously and adopt electric vehicles. Bhutan has abundance of hydroelectric power, clean electricity, a cheap and clean electricity, which can be used to charge these electric vehicles.
Thank you. This question from Mr. Nimal Pereira, probably from Sri Lanka. He's asking, what will be the total life cycle impact, especially with the focus of materials in use in the e-transport field? Have you given any focus on that during the carrying out this study?
No, what is the focus of material?
What is the total life cycle impact, especially with the focus on materials that are used in the e-transport fleets? Probably
No,
he's
the question is about the battery or about the motor. Question is about the battery or about the motor or the overall electric vehicle. What is it?
This is for the
Material.
overall electric vehicles.
Yeah, overall electric vehicles, many places. If you look at it, Tesla talks about you can drive to the moon and come back. We give you warranty because there are less than 2 dozen moving parts. So there is no vibration, as I said in the beginning. So it's a very long life for the electric vehicle. But in many places I have seen the life of a bus is taken still as 8 to 10 years. Some places 10 years, some places 8 years. So they are not. But battery, depending on the size of the battery and the battery chemistry and the usage, basically the usage is the main thing, and the weather conditions also a major influencer. So that depends, that determines the life. If a bus goes with a LTO battery, which can easily give you 10,000 to 15,000 cycles, the bus can run more than 10-15 years. But LTO batteries are too expensive today. It is, as I said, $700-800 per kilowatt hour versus LFP or NMC batteries, which are well below $200 per kilowatt hour, 150 to 200. So they all can give you life. It all again depends on how well you use it. If you misuse a battery, in 6 months it can go. So you have to make sure that the warnings are taken care. The DOD, depth of discharge, is never brought below 20% or 80%. DOD means 20% should always be there. So it should not be done. Even 10 times you do it, it's gone. And similarly, the charging and discharging in the bus, there is some temperature control, but charging, if you are charging at 48 degrees centigrade in Delhi, the life of the battery will have huge implication. And so you have to reduce the charging rate at 0.3 C or 0.5 C, not at 1 C or 2 C, even if the battery is capable of that. It's a complex thing. One side you try to optimize the maximum driving range of the vehicle, you have to compromise on something else. So it's a complex thing. The people will gain experience in each geography. One solution doesn't fit all. So the requirement in Delhi may be different than that is in Colombo, may be different than that is in Kathmandu and Tumbu. So it varies. As you use it, you will experience, you will know what to buy, how to maintain it. When I visited the Shenzhen one transport company, they had more than 100 patents over the previous 5 years on the maintenance of the electric vehicles. So they have invested in the R&D. Now from many other cities, people come to learn from them how these vehicles are maintained. So incidentally, when I asked them what was the biggest challenge in this transition, all the people now from the diesel buses, they have come to electric buses. What is the biggest challenge? The general manager told me the biggest challenge was to wash the bus. I had to finally throw out all the fellows who were in the depot who were washing the bus. I had to give them job outside of the depot. I recruited new boys and trained them how to wash it, because the washing fellows, otherwise typically they take a water jet and they start washing the bus. So here it is different. When the bus comes, they open the battery chamber and the engine area. There's a vacuum cleaner which goes and suck out all the dust, and then there's a brush which they brush it. So the actual water wash happens only on the glass of the bus. So there are different challenges, different thing. As experience start with small fleets and gradually increase to larger fleet, people will all gain experience relevant for each geography, each companies or cities requirement. Thank you.
Thank you. This question from Mr. Umar Yunus from Pakistan. He is asking that the electric vehicle model EVMM, does it take into account the readiness of auto manufacturers for EVs? How convinced are the auto manufacturers for developing EVs, and what are their major concerns?
Yeah, the fifth domain which I explained was EV technology, where electric vehicles, the motor, the power electronics, BMS, and the battery technology, those are all maturity of those things in a country is considered, and accordingly we recommended the roadmap based on the maturity of each of those countries in that area. So more details we will be happy to share on an email.
All right, thank you. We have now 3 more questions, and we'll try to go through them quickly. So the first question is from Mr. Akbar Yusuf. He's asking that owing to the higher energy efficiency of electric vehicles relative to the internal combustion engines, so there is a net reduction in energy supply cost to the economy. Do you have a quantification of the additional electricity and lower auto fuels and the corresponding dollar savings for India for a future year, say 2030?
There are a lot of studies. In our study, it is not part of that. It was not in the scope. So, but there are a lot of documents you can find in Niti Aayog with many other public documents. But it all depends on different assumptions. Yeah, it is very clearly established that in the present cost of electric vehicles, life cycle cost, there is a net saving. And also we, I mean, pre-COVID scenario numbers, if you take it, when the crude oil used to be above $50, yeah, there's a huge billions of dollars of export substitution. And the electricity mostly we are going to generate with coal, nuclear, hydro, and renewable energy. So we already have more than 80 gigawatt of renewable energy, which we plan to increase it to 450 gigawatt by 2030. So those programs are well on track.
All right. There's another question from India from Mr. Rajesh. He's asking, why don't we have one standard for charging infrastructure in India with various types of standard adapters for fitting into different vehicles? Is it feasible, or are there any issues in this regard?
We also, when we embarked on, actually the standard making is an exercise which we do by Bureau of Indian Standard along with all stakeholders, academia, industry, or the utilities. They are all part of it. So we make a technical committee which make the standards. So in 2016, end of 2016, ISGF requested BIS, Bureau of Indian Standard, to set up a committee for preparation of standards for electric vehicle charging stations or charging infrastructure. So that committee is Electrotechnical Committee ETD 51. It's working for the last 3 years. 2017 we constituted, and it's over 3 years we are working. So when we started, we were all very firm that we will go only by CCS and the latest version of CCS2, which adopted in Europe. That's what we will go ahead with. But then, as I explained, there are around 10,000 electric cars which are already in India, and all the buses which are being imported from China. They are all partially or fully imported from China. They all follow GBT standards. So we cannot stop that. So what we have done, our Department of Heavy Industries has issued a set of GBT standard as Bharat charger specifications, AC001 and DC001. So those are low capacity chargers, 15 kilowatt and 10 kilowatt chargers, 15 kilowatt DC and 10 kilowatt into 3.3 into 3. So about 9.9 kilowatt AC chargers. So these are to exist so long we have this Chinese vehicles imported in India. So it was a fait accompli. We cannot stop that. And then when we went ahead with CCS2, the draft version of IS 17017, and then the Government of India invited in 2018 several agencies, and Niti Aayog had interactions with automobile manufacturers. We had a auto show in 2018. So many of them from Europe, they didn't show interest in setting up manufacturing in India. It's only the Japanese and the Koreans said they will introduce the models, and both of them follow Shadamo. So we cannot say it. Then at the request of government, we said that okay, we will have, I mean, India is a large country. We will have millions and millions of vehicles. So it's okay to have all standard coexisting. So CCS2 and Shadamo are allowed in IS standard, which we published, IS 17017 part 1 and then part 21, 23, which is already published. And some more 3-4 standards we will be publishing later in the day, later in the year. And later, if Tesla start operation here, Tesla don't follow any of the standard. They have their own. Like Apple, they have their own standard. So Tesla will have their own. So US is also a very interesting example of Tesla standard. Tesla supercharger, they call it. They have GBT. A lot of Chinese vehicles are sold there, and they have CCS, and all the standards are existing there. The same thing will happen in and the Japanese vehicles, the CC and the Korean vehicles, the Shadow also exists there. So we will also have all that. Something very interesting which happened in the last 3-4 years, particularly 3 years, is that US and in India, the charger manufacturers have introduced a combined charger with 2 guns. One gun is Shadow, one gun is CCS. The additional cost of such a charger is only about 15 to 20%, because you have a separate controller and communication protocol for each of those. So charge controller is different for both. Otherwise, the grid connection part is same. So today it's becoming more common everywhere in US and Europe also. I see CCS and Shadow common charger with 2 guns, one Shadow, one CCS. So we think we have no choice. We will continue with this all chargers at the time being. Rajesh is from where? Which organization you asked this question, Rajesh?
Mr. Rajesh didn't mention his organization. He just mentioned his name and country. So we will request you to mention organization as well. With this, we have 5 to 6 more questions, and more questions are incoming. But because we are short on time, so we will request Mr. Kundu to stay on the line. And after we are done with the presentation from Mr. Alan Liu from China and Mr. Shakil from Pakistan, at the end of these 2 sessions, we will take on further questions, and we request Mr. Kundu to stay online for answering those questions, if that's possible for you.
Yes,
Okay.
I am there.
Okay, so we will request you to stay online till the end of the webinar, so that we could ask the rest of the questions after the 2 presenters are finished with their presentations.
Okay.
Okay, so with this, I would like to thank the team from India Smart Grid Forum for taking out time, especially President India Smart Grid Forum, Mr. Reji Kumar Pillai. Your presentation and your comprehensive, detailed explanation regarding the EVMM as well as the recommendations of the study. They must be very useful, and for all the participants, you can keep on sending your questions. We'll be taking them on towards the end of the session. We have also uploaded our draft report on our website, which you can download. I have just received a comment from one of the participants that he is unable to download the report. So we will upload the report, re-upload the report, and you can download it and read it for further information and guidance. So with this, now I would like to move on towards our next presenter. He is Mr. Alan Liu, founder and CEO of GH Energy. Mr. Alan Liu is founder and CEO of GH Energy, which is a top electrical vehicles solution provider and a state-level high-tech enterprise. For more than 5 years, Mr. Liu is an expert in distributed energy storage, B2G, and AIoT technologies. He served as an advisory and review member on the board of Chongqing's Renewable Energy Committee. He is also a state grid veteran, and he specializes in high voltage transmission. For over 10 years span, Mr. Allen has led a team of engineers and industry experts to implement several critical infrastructure and capital projects for the state grid. So Mr. Allen will be presenting on the topic of the road to electrification in China. With this, I am handing over the control to Mr. Allen. Mr. Allen, can you hear me?
Hello, can you hear me?
Yes, we can hear you.
Okay, I'm so happy to have a speech. First of all, let me introduce my company, GH Energy. GH Energy is the earliest charging station manufacturers in China. We cooperate with Tesla, do the supercharger stations in China, and BMW and SAARC. Now, in 2020, the GH Energy ran more than 2,164 fast charging stations in China. So, so today's speech is the road to electrification in China. So, the China is from 2014 to 2019. China's electric vehicles productions and sales have maintained a high growth rate. From 2014, the Chinese market sold more than 37,000 electric vehicles. Until 2019, the number is 1.24 million electric vehicles in China. So, in 2014, Elon Musk bring the first Tesla to China to completely deliver the China kick off the wave of car electrifications. Since 2014, more than 200 startups in China have been developing and manufacturing intelligent electric vehicles, including the NIO, including the iPhone, a lot of including the Ferrari Future, so many new brands in this market to making the electric vehicles. So we're going through the history similar like mobile industries, just like the iPhone. When iPhones comes, before iPhones come out, the Nokia, the Samsung, Motorola, things have so popular. But when the iPhones come, those companies are all gone. Now the replaced companies, the Huawei, Xiaomi, Oppo, Vivo in China. The same things happen in China now. When the Tesla is coming, the automotive, the energy, the internet, the 4G are changing and the reflectory. So the new industries become the new manufacturing, new infrastructures, energy substitution, 5G and smart industry is to replace the old industry. So why the China do this so strong, so powerful strategies to change the vehicles into the electric vehicle? Because the China depends on foreign oils. In 1919 has exceeded in 72%. Crude oils has become the country's biggest security risk. And the second part is the foreign exchange receipts. The country's core wealth were handed over to other countries in the form of crude oil to start all the enterprises that remain in China by electric achieve that the central governments must make. So, they promote the development of the electric vehicles from the Ministry of Industry and Information Technology of the National Development and Reform Commission by 2016. In 2016 to 2018, as Premier Li Keqiang of the State Prime Minister of Industry Development. In 2019, General Secretary Xi Jinping, the President of China, the traffic power risk raises a national strategy with the state electrizations in the first place. And now in 2019, and 2020, these things, what is the most powerful products in China's market? You see the left picture. The first picture is Tesla. Tesla Model 3, Model S, Model Y, maybe Model Y after 6 months later they were up to the market. And the BYD, the BYD, the duration is more than 600 kilometers, more than 600 kilometers. The brand named X-Phone, the duration is more than 700 kilometers. But the price, what is the price of this cars? The price is getting 20 and to 30 million yuan. And it all have automotive driving. The cost of use, the electric cost of use, 10% of the oil. And including the Daimler, the BMW, the Audi, the Porsche, Honda, Volkswagen, Jaguar, they all push their main highlight electric vehicles in China's market. Mainstream were launched in all electric vehicles soon in 2019. But China has become the world's largest electric vehicles market in 2018, accounting for more than 50% of the global market. But China has entered the eras of electric vehicles. So there are so many new brands in China was to have their products. I will show you a video. I just need 5 minutes. So this new brand named Byton was created by Chinese company, and then the that is put in the market in 2020. So and in 2020 there are some big things were happening in China, including the Tesla's Gigafactory 2 in Shanghai. And the Chinese major auto companies have also delivered ambitious plans on electric vehicles, and that the Chinese government's new infrastructure constructions plan also including electric vehicles charging infrastructures in key areas. So China's electric vehicles market will be the global electric vehicles market for a long time. So this is my presentation. Thank you.
Thank you very much, Mr. Allen, for your presentation. And the video was really, really interesting. We would like to request you for sharing this presentation as well as the video with us, so that we could upload it for the rest of the participants also.
Hello.
Mr. Allen, can you hear me?
Yes, I can hear you.
So I would like to thank you for this presentation and a very, very interesting video. And I would also like to request you to please share this presentation and the video with us on email, so that we could upload it and share with the rest of the participants in the SAARC region. This video was very interesting, and I'm sure they would like to watch it again. Also, we would like to ask you a few questions which the participants have sent in. So would you be available for the question answer session?
I'm sorry, I'm not very clear. The sound is small and I'm not very clear.
Okay, so I'll quickly ask you a few questions regarding your presentation.
Okay.
You can answer those questions. One question is that what is the longest distance covered by electric vehicles in China?
Why is in electric vehicles in China?
Yeah, the longest distance or the mileage of electric vehicles in China. The longest distance covered by.
I'm not very clear to you. Can you louder?
Okay, I'll type you the question.
Typing is cool.
So I've sent you a question. What is the longest distance covered by electric vehicle in China? So you must have received a question in chat.
Can you send me a text?
Yes, I'm sending you a text.
In WeChat or in this app? what is the longest distance overcalled by EV in China? 700 kilometers longest distance or call over. 700 kilometers.
Okay, okay. And which vehicle is this?
Which brand name you mean?
Yes, yes.
It means Xpeng. It's a new brand of the CEO is the co-founders from Alibaba. His name is He Xiaopeng. The P7 over 700 kilometers was last week. They are put the vehicles in market.
All right, all right. So the next question is, which I'm also typing in the chat, is can you talk about the policy measures taken by the Chinese government to promote electric vehicles?
Can you text it?
Yes, I've sent you in the chat as well.
Can you talk about the policy measures taken by the Chinese government to okay. Actually, the Chinese government have different kinds of strategies of electric vehicles growth. The first is give money. The government give money to the car maker, the customer, and the users. The second is the road authority, because for example in Beijing, Shanghai, Shenzhen, and Guangzhou, if you do not drive the electric vehicles, you cannot drive in the road in some days in a week. For example, if your car is oil car, you can just go Monday, Tuesday, Wednesday. But if you are an electric vehicle, you can go Monday, Tuesday, Wednesday, Thursday, Friday, every day in a week. So the second strategy is the authority of the road. The third policy is give some feedback to the customers. If you parking, the electric vehicles can parking free in first 3 hours in big city. If you are not in electric vehicles, you cannot parking free. And the percent of the car makers every year, if you are a car maker, you need to more than 15% of the electric vehicle, of your whole vehicles is electric vehicle. If you do not manufacture the electric vehicle, you cannot sell your cars in this market. So that is the Chinese policies in the electric vehicle. Can we please share the presentation and video? I can, yes, presentation and videos to you. That is okay. And I have a lot of fancy videos because the Chinese new brand, especially new brand, have so many technologies, including the autopilot, including the AI, the artificial intelligence, including there is a new brand named Li Shang. They have 7 screens in his car. You can touch screens in everywhere, and you can drive it in autopilot in highway. You can use the screens to play your game. You play the stock market. You communicate with your family and do everything. So there's a lot of fancy videos I can share you in internet.
All right. Thank you very much, Mr. Allen, for your presentation and for taking out time to explain the road to electrification for electric vehicles in China. Unfortunately, there has been some audio disconnection due to which you could not hear our voice, and we had to write the questions. I hope that you could hear my departing few sentences. With this, I would like to thank you for taking out time. And now I would like to move on towards our next presenter. So thank you very much, Mr. Allen.
Thank you.
So, dear participants, we now move on to the next presentation, which is by Mr. Shakil Sadiq Jajja, who is Assistant Professor at UMS. Mr. Shakil Sadiq Jajja would be giving his presentation on the topic of manufacturing readiness of battery electric vehicles in Pakistan. I would now hand over the control to Mr. Shakil, and I would also request him to please to give a short introduction of give short introduction and his profile in the beginning, as well as introduce the institute from which he is working, because for the rest of the SAARC member states, they don't know about LUM, so it's good that he introduces the institute as well.
Good afternoon, Umar and everyone. I hope you can hear me.
Yes, we can hear you and see your video feed.
Okay, thank you. So I think you can see my screen, presentation slides shared, and also you can see my video. So if that is so, I can continue then with the presentation.
Yes, please continue.
Thank you very much, Umar, for inviting me on this webinar. This is definitely very timely and interesting conversation in Pakistan and other SAARC countries. My name is Dr. Shakil Sadiq Jajja. I am Associate Professor of Operations and Supply Chain Management at Suleiman Daud School of Business in Lahore University of Management Sciences, commonly known as LUMS, Lahore. We started as a university, we started around 30 years ago as a business school, and currently we are a university holding 5 schools in one of them is business school, others engineering, science, law, social sciences, education. So these are the areas where the university is working, and this is they started as a teaching university or a teaching place, but then lately it has become a research institution, and a lot of emphasis is on research. I basically started 6 years ago at LUMS, and I have been working in the area of operations and supply chain management. So electric vehicles is something that I've recently started working on for last perhaps 2 years, but automobile is something that I've been looking at for many years. And automobile supply chain management has been a research focus for me for a while now. And I think this is the same for our national level automobile conversation as well, that battery electric vehicles conversation has recently started, and hopefully it will remain active and pick up as we move forward in time. So this is about me and my interest and the place I'm coming from. So Umar has invited me, and thank you SAARC Energy also, SAARC Energy Center, for inviting me on this webinar to talk about the manufacturing of battery electric vehicles in Pakistan in general, in the world also. So what I will do is I will give you an overview on 4 dimensions. In the limited time. I just have to hide this thing. Okay, done, good. So just trying to fix my screen so that I have a comfortable view of my screen and as I talk. Okay, so yeah, so I'll talk about 4 things briefly. I'll talk about various types of electric vehicles and why it is important to distinguish between them from managerial and from different standpoints that I'll talk about. I'll talk about global trends in manufacturing and adoption of battery electric vehicles. Then I'll share some of the notes that regarding the current state of manufacturing value chain of battery electric vehicles in Pakistan, and possibly if I get some time, I'll talk about what could be the future outlook of electric vehicles based on where we are today in Pakistan. So with this, yeah, so electric vehicles are, generally they're broadly speaking, battery electric vehicles is one. Then we have plug-in hybrid electric vehicles. Then we have hybrid electric vehicles. So you can see that in a typical electric vehicle, there is an element of electric power, and but the important thing about battery electric vehicles is that it does not have an internal combustion engine. And the other two forms, which is the plug-in hybrid electric vehicles, they have internal combustion engine. So I would distinguish battery electric vehicle as a very different class of vehicles in electric vehicles compared to the other vehicles that exist in the electric vehicles category. And why I think so is that why it is important to understand that battery electric vehicles should be treated in a very different way, is that these vehicles are different from other vehicles from consumer standpoint. For example, battery electric vehicles do not require a supply of fossil fuel. So they are only dependent on electricity powered mechanisms. So therefore, for the consumer, there is no backup. So there is just one type of power supply for this vehicle, and as a result, consumer looks at this vehicle in a very different way. In hybrid vehicles, this electric element is just an add-on on the original model, which is the combustion engine. So consumer's operation standpoint, the contingencies, the way consumer is going to use battery electric vehicle is very different from how the consumer evaluates the selection of the vehicle, as well as how the consumer is going to operate the vehicle. From infrastructure standpoint, meaning what is required for the vehicle to operate. Again, battery electric vehicle requires a very different level of development of electric infrastructure as opposed to hybrid electric vehicles. So similarly, from distribution and after sales service standpoint, the current business models of distributors of internal combustion engine vehicles work in a very different way. Their business model is very different. They make money in a different way. They provide different types of services. Their suppliers will be different if they move from hybrid vehicles to battery electric vehicles. So on that dimension, also battery electric vehicles are very different from hybrid ones. Manufacturing capability standpoint. So again, internal combustion engine capability, which is basically the key capability of the conventional vehicles or ICE-based vehicles, is redundant in battery electric vehicles. So again, manufacturing capability requirement of a battery electric vehicle is very different from hybrid vehicles. Similarly, business model standpoint. So you see, if you are a battery electric vehicle manufacturer, the resources that you need internally, for example, the battery suppliers or the motor suppliers or the body suppliers, they are very different from the supplier sets that you need for internal combustion engine vehicles. So right away, an internal combustion engine vehicle manufacturer cannot move to a battery electric vehicle manufacturing business. So business model is very different for both of them. Similarly, from regulatory standpoint, they are treated in a different way. For example, in countries which are just starting on battery electric vehicles like Pakistan or other countries in the SAARC region, how state is going to deal with battery electric vehicles is very different from how the state or governments are dealing with internal combustion engine vehicles. So I think that's why we should understand that battery electric vehicles should be examined and studied with a very different perspective as opposed to mixing them with plug-in hybrid electric vehicles, which have different dynamics and are very close to internal combustion engine. So the policies, the frameworks that we apply in battery electric vehicles should be very different. And that is key if we have to make this transition of transition towards electric transportation. If we don't change the way of looking at vehicle or the transportation in the new way of meaning looking at it from purely battery electric vehicle standpoint, we might miss out some important differences that should be noted for making this transition happen. Okay, so yeah, so these are the key components of a battery electric vehicle. It's a battery management system. It has a motor, controller, cables, and body. Yeah, so you can clearly see internal combustion engine and the gearbox and the transmission system in internal combustion engine based vehicles is completely gone. And remember, that's a key strength of internal combustion engine based vehicles. So for them to make transition to this new type of vehicles, which requires a very different system of supplies, is going to be a challenge. So therefore, you will see that different types of players are coming in battery electric vehicles as opposed to the existing automobile manufacturers. I'll talk about it more as we go towards the closure of this presentation. Okay, so now looking at the global trends. So electric mobility is expanding at a rapid pace globally. We can see that so in 2018, this is about a year old data, but still I think this makes sense. In 2018, the global electric car fleet exceeded 5.1 million and up to 2 million from previous years. So we can see that there's a huge rise in the number of vehicles, electric vehicles on the roads. Yeah, so battery electric vehicles account for 64% of the world's car fleet, and China remains #1 in terms of the total number of vehicles holding in a country, followed by Europe and United States. However, Norway is the global leader in terms of a market share. So the adoption rate or conversion rate in Norway is the highest, whereas the total number of vehicles in a country are the highest in China. Yeah, so and there is this Vision 30 in 2030, which says that 30% of electric vehicles will be 30% of the vehicles will be electric vehicles by 2030, and many countries have signed this, and Pakistan hopes to be one of them with the passing of current electric vehicle policy in Pakistan. So this is a split of a global split of electric vehicles in the world. So China holds 45% of the vehicles, 24% are in Europe, 22% in the United States, and the rest of the world has 9% of the electric vehicles. Okay, so this basically tells us the trend in terms of how the adoption of electric vehicles is happening across the world. So we can see that China is leading and in terms of number, and it is happening exponentially now. So if you look at in last 7 years, there is perhaps 100-folds increase in number of electric vehicles in China. Similarly, in Europe, the trend has been very encouraging. United States has seen good growth in electric vehicles, and the rest of the world is still following up. Within Europe, if you look at Norway, Germany are the leading ones, and then United States. In Asia, Japan is you can see that it's picking up, and similarly other countries. So the overall takeaway from this is that all over the world there is a rising trend in the adoption of electric vehicles, and this is growing. Okay, so what are the drivers of electric vehicles adoption? So energy efficiency, clearly we see that energy efficiency is very high for electric vehicles. It's 3 to 5 times more energy efficient than conventional electric vehicle, internal combustion engine based vehicles. Energy security, it is reducing dependence on oil-based fuels and import bill of many countries. But given the now you might be thinking that recently there is a huge decline in the oil prices because of the COVID-19 crisis and some other factors. And so how will this affect the adoption rate? Yes, this is going to be, I think, a hurdle in the journey towards adoption of electric vehicles. And we will see that how long this takes, but as we know, these oil prices historically have been going down and then coming up. Although there is not, this instance is very rare. Still, there is a strong hope and strong understanding that the oil prices will bounce back, and as a result, this price difference in terms of operational cost of electric vehicles and internal combustion engine based vehicles will come back. Similarly, air pollution, greenhouse gas emissions, noise reduction, all of these are the benefits that electric vehicles are bringing. Yeah, so these are the state level, or you can say the macro level indicators or the drivers of mass adoption of battery electric vehicles. Now the other driver is the price of electric vehicle. So price of electric vehicle is the cost of electric price is the one that consumer looks at, but the cost of manufacturing is important from manufacturing standpoint, and they both are associated to each other. So in general, 40% of the battery electric vehicles cost is the battery cost or battery related cost. So therefore, it is very important that how the cost of batteries, battery manufacturing and battery for the consumer has been changing in the past. So we can see that there is a trend that batteries, cost of batteries manufacturing and usage has declined very, very rapidly in last 10 years. So in 2010, the battery price was around $1,000 per kilowatt hour, and by 2025, this is expected to go to $94 per kilowatt hour. So this is almost 10% decline in 15 years, or you can say that it's 8% decline in 8 times decline in 10 years. So huge research and development going on in this battery manufacturing, and as a result bringing the battery cost lower. Similarly, there are some new technologies coming up, such as graphene technology and supercapacitors, which actually claim that the cost of battery will actually become will not be a factor anymore, because of these technologies, the cost of battery manufacturing and usage will be negligible compared to the overall other factors in the decision making of adoption of battery electric vehicles. So this happening in parallel. Yeah. So now within batteries, lithium-ion battery is the one which is currently the most promising one in the automobile manufacturing. So lithium-ion, if you look at how the R&D is happening here and who are the main players. So you look at so companies like Sony, LG, Panasonic, Samsung, they are holding majority share of the lithium-ion battery manufacturing. So, and all of them are South Korean companies, and we are seeing that there is a lot of research going on in the lithium-ion battery manufacturing. And for the time being, this is the type of battery which is being used for, which should be used for automobile manufacturing purposes. Although in some developing countries, lead acid based batteries with some combinations are being used as well, but primarily it's lithium ion based batteries that are being put in automobiles. Now, giving you a view of what kind of policies governments are across the world taking to encourage adoption of electric vehicles. So, for example, there are policies on fuel economy standards, fiscal incentives, economic instruments. So, for example, they are giving targets of average fuel economy. They are giving tax credits to manufacturers and consumers to enhance the adoption of electric vehicles, free registration and license plates, lower toll or parking fees, access to bus lanes. So all of these are the incentives that are coming from government side. Also, different governments are putting different level of emphasis on battery technology value chain, because as I said earlier, battery is almost 40% of the cost of manufacturing of electric vehicles for now. So therefore, a lot of emphasis is being put on developing battery value chain in countries where manufacturing of electric vehicles is happening. Similarly, on the adoption side, governments are encouraging and introducing procurement programs to buy large volumes of electric vehicles, so that there is a demand of electric vehicles, and it makes business sense for the electric vehicle manufacturers to move into this business. Similarly, infrastructure support policies are being developed and announced and implemented so to encourage the adoption, and similarly interoperability of various types of charging infrastructure is being worked on. I think this discussion has been happening today also in the webinar. So another, I think there are different examples of adoption of success of adoption of battery electric vehicles, but I thought I would look at or share some findings from China, because they have the largest pool of electric vehicles. So it has the biggest manufacturers also of electric vehicles. So China has the largest number of electric vehicles, as well as the largest number of and the biggest manufacturers of electric vehicles. So more than half of electric vehicles in the world are coming from are going in China. Also, their electric vehicle market is 3 times larger than the US market. So this I've already shared. So they have very encouraging targets for next 10 years. So for example, their new electric vehicle policy says that 7 to 10% of their vehicles in 2020 will be electric vehicles, 15 to 20% by 25, and 40% by 40 to 50% by 2030. So these are very, very encouraging targets. Yeah, so along with that, they are putting pressure on manufacturers that they have to make their vehicles, those who are not into electric vehicles, they have to make sure that their internal combustion engine based vehicles are following tough economy standards of fuel for combustion engines. By the way, Omar, this is presenting to screen is very difficult. So current fuel economy standards are to be used till 2020. Yeah, so these are some of the China manufacturing trends. Yeah, so these are some of the initiatives that they are taken on the manufacturing side. So I think I will quickly perhaps skip to battery electric vehicles value chain in Pakistan. So in Pakistan, this conversation has recently started, I think 2-3 years, not more than that. That's some serious entrepreneurial, I would even say that serious only at entrepreneurial level activities have started. So Power Electronics Pakistan Limited, they are working on 3-wheeler electric rickshaws. Jolta is a company which is working on 2-wheelers, and they have recently launched also 2-wheelers, electric 2-wheelers. There is another company in Karachi. They are currently planning to import from China and then market in Pakistan. There is another company which is Energy Islamabad, which is developing their own vehicle and from scratch, and they have developed their own battery management system also. And looking at the existing automobile manufacturers, as I was saying earlier, that since this battery electric vehicles, this is a completely different business model, requires different technologies, capabilities, supply chain, pricing, after sale and distribution, consumer mindset, and infrastructure. So therefore, existing companies in automobile manufacturing are not the best prepared to enter into electric vehicles unless they open up a new arm for this business. So in Nishat Hyundai, for example, they have recently started. So we had a conversation. So they are looking at electric vehicles as in their long-term plan, but certainly not in their short-term plan. Similarly, for Atlas Group, they are looking at it, but I think this is not a part of their short-term plan. Sasgar Engineering, however, which was a smaller player, has launched 3-wheeler electric vehicles, and they are, I think, also looking at 4-wheelers. Omega Industries, again, 2-wheeler, but since they are into internal combustion engine, so they are currently not looking at it in the short run. Okay, so at component level in Pakistan, battery manufacturing is the key, and so far in this, there is only lead acid based battery manufacturing happening in Pakistan, and the business model and the business sense for lithium-ion battery manufacturing is so far very doubtful, and there is a lot of skepticism that how the demand pattern is going to be in future. So there is not much effort going on in setting up a plant of lithium-ion battery manufacturing. However, there are small size efforts going on where people are importing battery cells from China and then assembling them for you can say sporadic and small demand sources. Similarly, motor manufacturing is the second most important component or capability required for battery electric vehicles. So Gujranwala in Pakistan and Karachi to an extent are considered to be the hubs of motor manufacturing. So currently the understanding of this DC motor is minimal from the standpoint of manufacturing it for electric vehicles. So a lot has to happen in that space for it to be ready for battery electric vehicle motor supplying source. Yeah, so other organizations, other sectors such as fan manufacturing or maybe light engineering, they could be possibly looking at this sector as a potential market. So cables, cables is something that I think we are most ready in. I think for electric vehicles, and the required information or sense is there. Controller is again something that we are not much good, nothing much as far as the needed capability for battery electric vehicles is concerned. Though there are companies which are trying to put effort in small scale controller setting, controller making. Jolta has done some work, Energy is doing, and there might be some other companies, but certainly not at significant level. Yeah, so there is a lot of conversation in universities and R&D institutions, LAM School of Science and Engineering, NED Karachi, UET Lahore, UET Peshawar, LAMS Energy Institute. All of them are doing some effort in different components of battery electric vehicles, and this needs to be geared up. There are some international players also who are interested, and what possibly they can bring in is battery packs, battery management system, motor controller, and battery swapping system is what can come from there. Okay, so from the consumer standpoint, the economic sense of BEVs, certainly it makes sense at the operating level, but the upfront cost is very high. So there are companies which are trying to make local designs that can compete the internal combustion engine based vehicles prices to address this upfront cost issue of electric vehicles. Operating cost, as I said before, is already very attractive. So recently, the government of Pakistan announced National Electric Vehicle Policy, and this is, I think, the first main step that was needed in creating the space where private sector can come in to play their part in the electric vehicles value chain. Yeah, so Pakistan is also hoping to become a part of the International Energy Agency's 30% at 2030 initiative. Green banking regulations of State Bank of Pakistan are already there, that they can be leveraged by electric vehicle manufacturers or suppliers or others in that business. Okay. So possibilities, I think key components where Pakistan's manufacturing industry needs to work is EV kits, batteries, battery management system, motor controller, body and cables. So EV kits, I think in 2 to 3 wheelers, this will be a easier journey, and a lot of work has already happened in that space. In battery, again, lithium-ion battery battery manufacturing in Pakistan needs to begin. battery management system critical for Pakistani environment, because the temperature here you see varies, especially the road temperature from 0 or minus to 50 degree plus centigrade. So that's why indigenous or a battery management system that can meet the requirement of Pakistan's environment is required. Similarly, a lot of work is required in motor, controller parts. Okay, so financing, yes, as I mentioned before, upfront cost of electric vehicles is high. Therefore, there should be some loans for battery electric vehicles or battery leasing models for cars and batteries. And perhaps the best starting point to begin is 2 to 3 wheelers, commercial vehicles, and institutional customers. Okay, so enhancing demand versus, yeah, so at the policy level, there is a challenge that you on one side you want to enhance demand, and for that what you do is that you create incentives for buying electric vehicles. But if you don't have supply base ready in Pakistan or in SAARC countries, then other sources of international manufacturing will be sending their cars in these countries. So that will compromise the local development of electric vehicles. So the government has to create a balance between creating a demand as well as putting effort to localize the technology for battery electric vehicles manufacturing. Okay, so for that, with that, I think I will close the presentation and I can take questions if there are any. I could not see any participant, and this is a very different experience of presenting. Yeah. Okay.
Thank you very much, Mr. Shakil. We have a participation of around, earlier in the morning we had participation of around 70 to 75 persons. Right now we have a participation of around 30 people. I've received a few questions which the participants have asked from you, mainly from Pakistan. So the first question is, what is the current status of EV policy in Pakistan? Probably this question is arising because there is still some confusion. Has the policy been approved or not?
Yes, so currently the policy is out there. It's already approved and it's available. I think if you can share it, I can share it with somebody who is interested in having it, and it's already there.
All right. So another question is regarding the Energy Institute at LUMS. I don't know if you are you can talk on their behalf, but the question is regarding the current research, policy level research, which they have been doing for, especially in regards to Pakistan's EV policy.
Yeah, so LUMS Energy Institute has been working with government of Pakistan for a while now. I think they were very helpful in putting up the first draft and giving input in different dimensions of the EV policy. For example, how to increase the demand, how to develop infrastructure for charging, how to help local industry to develop manufacturing in Pakistan, how to excite new players come in as original equipment manufacturers, what kind of taxes and incentives should be launched for this to happen. So all of this is what has been fed into that policy, and this is what the LUMS Energy Institute has been doing. Another important work I think that they have been doing, and this is perhaps the most fundamental work they are doing, is the overall energy utilization optimization in the country. So they have been looking at the energy production contracts as well as the future demand pattern of energy and how the future supply of energy is for next 10 years or 15 years. So, and based on that, they have been giving input to the government that what kind of policy should be acted on. So out of those, out of that insight, one insight out of those that work, one insight is that the energy is going to be surplus for next 10 years in Pakistan. And there are different ways of using that energy. One of them is electric vehicles. So electric vehicles adoption is you can say is one way of benefiting from the excess supply of energy that we might be seeing in next 10 years or 15 years.
All right. So the next question is from Mr. Muhammad Ali Qureshi. He's asking, does the EV policy of Pakistan complements the Pakistan automobile policy?
Yeah, so these are two different documents. The Pakistan Automobile Policy 2016-2021 is a separate document, and it does not talk about electric vehicles. So therefore, there was a need for a policy on electric vehicles. So one way of doing this was to amend or change the Pakistan Automobile Policy. The other way was to come up with a new policy for electric vehicles. So what government of Pakistan has done is that they have made a new policy on electric vehicles as opposed to changing the Pakistan Automobile Policy 16 to 21. So basically now there are two different documents.
All right. With this, we reach the end of the questions for this particular session. I would like to thank you, Dr. Shakil, for taking out time from your schedule and giving this presentation. Here, I would also like to inform the participants that this presentation has been informed from one of the studies that LUMS and Dr. Shakil has done for SAARC Energy Center. It was regarding the battery electric vehicle manufacturers' readiness for Pakistan, India, and Bhutan. So I'm sure Mr. Shakil would further be explaining and disseminating the results and findings of his study in another session, which will be organized by SAARC Energy Center in near future. So thank you very much, Dr. Shakil, for taking out your time from your busy schedule and coming here to disseminate the findings. Now we would like to move on towards Mr. Sudhasudha Kundu from India Smart Grid Forum, and we would resume our question answer and the feedback session which we had left off before Mr. Allen. So we have a few questions here. I would directly ask them from Mr. Kundu. The first question, so first of all, Mr. Kundu, can you hear us?
Yeah, I can hear you. Please tell, please.
Perfect. So there are a few questions remaining. The first question is with regards to Bhutan. So the question is, you have mentioned that Bhutan Power Corporation can invest in areas like charging stations, but the person he's asking that the Bhutan Power Corporation may not be ready to invest for such infrastructures, as these are very cost intensive and may affect the overall domestic electricity tariff. So what is your recommendation to take this forward?
No, see, there are various business models that they can work on. So this one that he has mentioned rightly, that it's a cost intensive and there is a tariff there is impact on the tariff. But the countries which have gone through this type of business models, what they have adopted is that, and we also developed one of the utility in India, that if you put some charging stations, around 100 charging stations inside a city. Some 100 charging stations inside a city, and if you can distribute the tariff, means the cost that is being incurred throughout the consumer base, there is hardly any increase in the tariff, or hardly 1 paisa or 2 paisa increase in the tariff. Right, so it will not be, but the thing is that it will not be distributed only across the EV consumer base which is adopting EV, but across the whole of the consumer base. So then if you do that distribution, if you can find a model, you can build a model on that, and you can put the parameters and everything, put the figures of what is the cost that will be involved in putting up the charging stations, and what is that impact on the tariff. You will find hardly a 1 paisa or 2 paisa is coming. However, there is a political, altogether political ballgame altogether, the whether they will approve that or not by the regulatory commissions or something. But in Ireland, like ESB, which is the grid operator, that is being they are handling that. So you can find various examples of that. So it's not like that it will not be, they will not be able to do that. But otherwise, there are alternate solutions also, like what India is doing. The central government is giving some subsidy on implementation of charging stations to various city municipalities or city authorities. You can avail that subsidy and you can put up charging stations. The subsidy is varying subsidy actually. For putting up in malls or parking lots, the subsidy is something different. And for putting up in, means if they are doing by cooperatives, the subsidy is something different. So this type of models also you can go by. On considering a Thimphu, a smaller city, or Bhutan, a smaller country, third-party investment can come up if Bhutan government is willing to transform all the transport to the electric transport, because private party will only come when the ROI, that is return on investment, is achieved. Otherwise, it will be not be a business case for them. Thank you.
Thank you. The next question is, what measures in terms of technology localization for electric vehicles are taken in India, and what sort of instruments are in place to promote the technology innovation in the EV sector?
See, in India, there is various localization. People are preparing charging stations right now. The lithium-ion batteries, they are doing it. The smallest lithium-ion batteries for at least 2-wheelers, for 3-wheelers, they are making. For this, means bigger, much larger batteries, or FDI is being done. I think Toshiba is coming to India for this battery manufacturing plant. Assembling plants are already there in place 2-3 years back. This what is the assembling of the buses, or Tata is doing the assembling of the electric buses. This what is called these 2-wheelers, 3-wheelers. This Toto is being getting manufactured in India. What is called electric 3-wheelers are getting manufactured in India. 2-wheelers are getting manufactured in India. So charging stations are getting manufactured in India. 4-wheelers are getting manufactured in India. So already these things are in place. Retrofitting of electric trucks are there, and then electric trucks already is not currently not manufactured in India at a very high level, but already suppose 3-ton or 5-ton or 7-ton capacity electric trucks are there already being, I think Tata and Mahindra have announced for that. So this type of technology localization is already there. What is the second part of the question, Mr. Omar?
The second part of the question was that just a second.
Instruments, right? Yeah, what instruments?
So what sort of instruments are in place in order to promote the technology innovation in the EV sector?
No, see, EV sector, there is a MNRE, that is Ministry of Renewable and Ministry of what is called New and Renewable Energy, has already come up with a policy guidelines on this to promote the research and development on the battery side. And there are also the instruments, the policy drivers, there are special manufacturing zones are being created for putting up battery plants and these EV plants. And in the policy in some of the states like Uttar Pradesh and others, and the what you call, there's a EV manufacturing policy came up, which supports the manufacturing of electric vehicle and parts and equipment. There is a reduction on incentives on the import and electric vehicles, some of the state-specific policies. In India, there is no national level policy, but there are various state-specific policies, and ministry-related policies or regulations or guidelines are already there. Thank you.
Thank you. There's a question from Mr. Ugin User from Bhutan. He's asking, what are the best policy instruments that governments should put in place to incentivize people to adopt EVs? So you have already answered part of this question in the previous question, but probably you could, explain some policies relevant to Bhutan.
So see, policies relevant to Bhutan is that there are various business models you can adapt, which can help you to accelerate the deployment of EV. If initiatives are not from the government. Hello. Hello.
Hello, yes,
Hello.
you're audible. Yes, you're audible.
Audible, no? Actually, someone from your side actually muted me. So.
Yes, by mistake.
No, actually, what I was saying is that in Bhutan or someone, the government has to take the initiative first, because when there are the number of EVs that are already, EV is already in nascent stage, and it needs to be promoted from the government side first, right? Because consumers will only, because consumer awareness, you can do that, but when there is no push from the government side, it will be difficult for the consumers to adopt that new thing or the EV. So for the government side, what in Bhutan, what can be done is that Bhutan is mostly rich in tourism. So in tourist destination or tourism council, they can start doing they can start implementing or deploying EVs for tourism operations. Right. This will give at least give the outsiders or the other people who are coming from outside countries that it's a carbon neutral country, Bhutan, which Bhutan already declared it's a carbon neutral country. So this will give a boost to that, right? And with this tourism operations, when the normal people have started driving this, then they can share their experiences and their what is this, less fatigue and everything, on is easy to use thing that can share with the consumer, which will increase the consumer awareness. From the government side, this tariff I told, there is a highway toll tax. One of the business model you implement, what do you call you introduce the cost of setting up charging stations into the highway cost, right? And charging that back through the toll tax. So you can do that, because that will increase hardly a 1 rupee, or in Indian scenario, it's hardly increase a 1 to 5 rupees in the toll tax, which is very minimal for anyone, because most of the toll tax that people are going is by 4-wheelers or by buses. So 5 rupees for one side increment, it will not be difficult for the consumers to pay also. On the incentives on this import of electric vehicles that they can give, sufficient incentive, or the creating of special EV zones where only EV parking will be allowed, or special or exemption in road tax, or the license fee for the driving EVs, green number plates that is already in India to separate out EVs from the other four-wheelers. So these type of things you can do, which can promote and parallelly can increase the consumer awareness. Hello. Hello.
So yeah. So the next, yes, we can hear you.
Yeah, sure.
Can you hear me?
No, it's complete.
Yeah. So okay. All right. So the next question is from Mr. Tolaram. He's asking that what is the longest distance that is covered by four-wheelers manufactured in India?
Manufactured in India, I think it is by Tata Nexon, that they are giving I think around about 200 kilometers, almost something more than that.
Is it
Maximum,
a hatchback?
It's a hatchback. Actually, it's a what is called crossover. Actually, SUV and hatchback crossover.
All right. All right. So there's another question from Mr. Tolaram. He's asking that in life cycle costs, have you quantified the environmental cost? If so, then how it is quantified?
In the life cycle cost of EV, obviously when we are doing that, is the environmental cost is already being included. And how you quantify? You can quantify by what is that, the savings in the emission that is being done, and with respect to the emission that is being carried out with the IC vehicles. Actually.
So you are giving a monetary value to the emissions?
Yes, you can give a monetary value to the emissions, because the savings that we are doing by cutting the import of the fuel oils and the import of that fuel oils, and also the savings that is being done by those fuel oils in the emission of the linkage, and you can.
All right, all right. Then there's a question from Mr. Awais Khan from Pakistan. He is asking about the distribution network condition in India after the induction of EVs and how they tackle the distribution network conditions, and what are the key suggestions in this regard?
See, in the distribution network, currently the influx of EV is not that much that will impact the distribution network. Obviously, in for the buses and others, what we are doing is that we are developing an on-site substation and a dedicated 11 kV feeder. It is already in the Ministry of Power guidelines for India. They need to have a separate transformer. You need to have a dedicated 11 kV feeder, the cables and everything for this electric vehicle. But the impact on the total distribution network, that we are doing already a study on the planning of EV charging stations in Bangalore, that already Mr. Reggie has already been described the study, that what we're doing in the feeder with PV and EV and everything, and also the influx of EVs in those regions, how it will impact the distribution feeder. So we're doing a study on that, how the harmonics will impact on that, what is the voltage and everything. So this we are already carrying out a study, but in the future, obviously distribution network upgradation will be required, because in home also, if you are putting a charger in, it is a single phase, then you have to move it to the 3-phase, because in India, single phase is 7 kilowatt, above that it will be 3-phase. So that 3-phase thing will be there. Then load balancing in the phases, that need to be there, because in one phase, if there are more charging stations in another phase, so that needs to be taken care of. The cable values, the cables that are already being used in those areas for connecting to the grid, and those cables values need to be checked whether they have the capacity to take up the means power fluctuations and voltage and other harmonics and everything. So upgradation is needed, but with the more EVs to come, the upgradation and smartness of the grid, that also will need.
All right. So it's in continuation to this question, I have my own question regarding the 3-phase versus single-phase chargers. So for the EVs, like the electric vehicles, not for 2-wheelers but the 4-wheelers, aren't the most of the chargers are already 3-phase, which are being used for the home charging?
No, already 3-phase for 4-wheelers, it's not a problem. But three-phase also you will face a problem. You will face a problem when there will be load balancing in the phase. There will be a problem because there will be 3-phase, right? In every phase, what is the load and how this load is reacting in that time, that will help. That will impact the distribution grid, means 3-phase system. So then the
from
problem
the macro
is there
point
from
of view.
side. Yeah.
From the macro point of view, from the distribution company's point of view, the 3 phases might be out of sync. That's what you are saying.
3 phases might be, that they have to do the load flow studies and take care of those things normally. They have to take care of those things. That's what I am saying, because 3 phases everywhere that will be a problem, because when you're putting extra load on that, and these are all non-linear load, so harmonics and voltage fluctuation, power quality problems will arise. So you cannot avoid that. The utilities need to take care of that when the number of EVs will be there, because in UK there is one situation where this problem has already arrived. So utilities need to take care of that.
Thank you. So another question is regarding the 3-wheeler model, which was suggested by Mr. Reggie Pillai. The question is that which battery type is best for the 3-wheelers model, which Mr. Reggie has suggested. Furthermore, for battery leasing model, how will it be ensured that how old is the battery, and how will it be ensured that low performance batteries with low mileage isn't being given to the auto drivers from the distributor?
See, for the 2-wheelers like India currently, what they are doing is that one is ICAT approved body of this side. So you can take the 3-wheeler, and if you can put the battery by yourself, so most of the 3-wheelers design will be almost equal, right? So you cannot say that this what you call these batteries, the batteries that will come in the 3-wheelers, that will be of different quality or something like that, because the batteries and everything that will be there, that will be company made batteries, and the leasing stations will be taken by companies, or someone will have a tie up with the companies who are manufacturing those batteries, especially on lithium ion, right? And on the other side, if it's on the old battery or other battery, obviously if the old battery is there, then the leasing company will also face a penalty. Because of that, they will take a long time to charge, right? So obviously they also will do a business. If it's a business case, then they will also do a business. Why it can be charged quickly and give it to the customers, right? So obviously the leasing companies will not use the older batteries, which get charged for long, and then because when they will charge it for long, they will have to pay the price of electricity. So
all right,
you got my point.
so Yes. The final question is regarding the EV markets. The question is that the EV markets are currently regulated by the countries, by the policies of the respective countries. So if the EV market is totally deregulated, what will be the main disadvantages apart from the disadvantage of standardization?
This deregulation in the EV market is deregulated. Currently, the EV is not at the stage of deregulation. It's not in any way. It's regulated also right now because people are trying to build in that area. Right. So regulations are also not fully developed, but that not only from what do you call this standardization, the what is called what do you call this standards, quality, non-conformity, quality, and others. These challenges will arise. So when there is a nobody above that body to monitor the standards or the quality of the materials that are being used in that in manufacturing or the import of those materials, if there is no overarching body to measure that or to look after that, then there may be a problem, in my view.
All right. There's one more question.
Is this, no, I am asking. I have satisfied with the answer, or you are asking from other prospects of marketing and others? That's what I'm saying.
I think the question was in regards to the free market principle of free market economics, that the free market should drive the economy and should drive the policies. So maybe it was from that perspective that would deregulation bring in further innovation and further benefits.
Innovation. Okay, then innovation and benefits that free markets can bring in without like what you call currently doing it in blockchain, so that it should not be regulated, right? But EV, there's no disruption is being done by other industries except the auto industry. I understand in some places they are trying to put up their lobby and doing that, trying to stuck that innovation and other things. But there's the lobby will see if there is also a free market, that lobby will again work. Maybe not at that level that automobile, but there is some means what you call some people or some companies will be there. They'll be lobbying for something. They'll be lobbying for something. Right. Total free market is nowhere in the world, whether you call it or not. Some institution is always there to monitor you, right? And someone will always take their preferences above others. So
correct.
We should take a balance between both government regulations and the free market what companies are trying to bring on board with innovation. We should promote those innovations through a centralized way, actually, right now.
Thank you. And there's another question regarding the battery. The questioner has asked that which battery type is best for two-wheelers and three-wheelers currently in India? Is it the lead-acid battery or the lithium-ion battery?
No, lithium-ion. Actually, in Sundarban, we did a comparative study with lead-acid and lithium-ion in three-wheelers. It is fine. Obviously, the payback period, if you see, it becomes much lesser because the first means what you say, lead acid battery after 1.5 years you have to change, right, for these three-wheelers. And lithium-ion battery is period for the 6 years, 7 years you can take it, or 5 years for the case of three-wheelers, minimum 5 years. So when you put up the case and do the cost-benefit analysis and the payback period, it is lithium-ion has a better payback period than the lead acid.
All right. So you have quantified in the form of studies that the lithium-ion is cheaper in terms of payback.
We did some actually we did selected some routes in those areas, and we did an on-ground study and a detailed discussion with the stakeholders or the three-wheeler drivers actually and the unions, and we collected data from them, and then we did analysis, and there we found out that lithium-ion has a better payback period than lead acid.
All right. There is a question about the EVMM, the EV model, but I would ask the questioner to send it again because it's I can't understand the question. Probably this is about the quantification of the readiness of electric vehicle manufacturers. Are they does the EV model, I think it says that does the EV model take into account the readiness of the electric vehicle manufacturers for building the electric cars? The question seems to be something like
Yeah,
this.
obviously it has been taken care of. Obviously it has been taken care of.
Yeah, okay. So I think with this we have reached the end of the questions and answers. I would request the participants that if they have any other question, they can send their questions in email, and we would forward it to the study authors. Or if you have any particular recommendation or feedback regarding the report, you can send in all your feedbacks to me in the email. The email has been given on the SAARC Energy Center website. The draft study report has also been uploaded on the website, so you can study the report in detail in your free time, and then provide us with your feedbacks. We would love to incorporate your feedbacks and your comments in the study report. And with this, I would like to thank you, Mr. Kundu, for staying with us
Thank you.
in the question and answer session. And of course, being the study author, you provided a very comprehensive overview of all the recommendations which you have drafted for all the 8 SAARC member states. And we thank you for presenting these recommendations. I would request the participants to please go through the recommendations for their respective countries, and provide us in particular feedback for those recommendations. Do you think, because the study was carried out in 2018, so if anything has changed by in the last 2 years, so we would love to hear your comments and feedback so that we could incorporate and update our study report. So with this, I would like to thank all the participants, all the panelists, everyone who came around to participate in this webinar. Please join us in next upcoming webinars as well. Because of the COVID-19 situation, we have been carrying out our activities through digital means now. So we would be having our webinars in regular intervals on a weekly basis from now onwards. So I would like to take this opportunity to invite the participants, current participants, to our next webinars. All the presentations and the videos which have been shown in this webinar, they will be uploaded on our website. So you can visit our website www.saarcenergy.org and gain access to our presentations. So with this, thank you everyone, and goodbye and take care.